Good
Well, good
morning,
morning,
everyone.
everybody.
Welcome to week 5 of our training. This is our final week of the training. Thank you for hanging in there with us. We hope you've gotten something out of it. We're going to have some discussion about that towards the end. But this week we are working predominantly on energy calculations. We'll have some conclusion discussion as well and a little bit of surprise slides per your request right before that discussion if we have time. We'll also be passing out a survey at our first break. This survey helps us to understand what worked with this training since it is a pilot, what didn't work, what you thought of it. It's your opportunity to give us feedback. And Ted and I both really appreciate feedback and honesty in that feedback. You know, filling us full of smoke doesn't do us any good. We want this training to get better and better every time we uh, iterate on it. So you can see our general schedule there that we covered. Our and like I said, we're going to be doing a lot of energy data today. We will have our presentations from some of the folks you heard from in our first session, Dr. Peter Crabtree, Jingjing Liu, as well as Larry Chang will be leading some of those ending discussions for us. As always, hey, we're learning as a team. We've got as much to learn as you do. So please ask questions, share experiences. Because we are short on time today to make sure we get in everything that is going to be useful to you, we do ask that you keep questions and comments concise as possible. Ted?
Yeah, so with that, Robert actually kind of already introduced a little bit, but we're going to, in the first half of the day here, talk about meter data, interval data, and utility bills. And this will give you a basis for understanding what you're monitoring from an energy standpoint and how you apply costs to that. As Robert mentioned, we hope to get about 5, 10, 15 minutes in a discussion about VFDs. Robert has some slides prepared that are very interesting. We went through them this morning, and it's good information. This gets us into our homework discussion. I know you will be wrapping up part of your homework today in the next session where you're going to be downloading your trend data, and you set that up last week, Friday. But you're also to find a utility bill for your facility and look at that and think about it. Was there any other aspect, Robert, that you wanted them to talk or look into for the utility bills?
Nope, nope.
So this is going to be a discussion. We want you to open up and tell us, what you thought about what utility bills are. Which utilities do you have at your facility? And maybe you only grabbed one bill from one particular source, like electric or something like that. That's fine. But just let us know what types of utilities you have. I know it's going to be a little bit different because we have a number of people from Alaska, and they may be, in particularly they're generating their own energy. So bills will be a little bit different than what Robert and I typically think of. And so we will work with you on that to make it more relevant. We're also would like you to talk about what is or are the most important parts of utility bills and why, and which ones are the most important to you. And what do you see on your bills? What type of information did you notice as you're looking through your bills over the past week? So with that, I'm going to open it up for discussion. I'll start out a little bit. I noticed that my firm has done energy tracking for the past 30 years. And in reviewing that data here in the Midwest, and I think throughout the United States, when you compare the two different utilities of natural gas and electricity, the natural gas costs are often much lower than electricity. And that's one thing I have noticed over the years. There's probably good reason for that. Just a lot has to do with infrastructure and the source of the energy. But it does make energy conservation of natural gas items a little more difficult from a payback standpoint. But we should be looking at payback anyway. We should be looking at what the return on investment is. So anybody else have some ideas? What did you find on utility bills?
Yeah, here in Alaska, this is Jessica from Kodiak.
Hi, Jessica.
The fuel costs are the absolutely most important one for us anyway. Here in the town of Kodiak, we have an amazing electric utility that's mostly renewable. We have a huge hydro dam and a bunch of windmills, so it's like 99% renewable. But when we go out to our villages, we're like shipping fuel out there, paying people to take their skiffs over across the bay to the nearest plant to bring the fuel back. So our cost per gallon for diesel is you know, around $10 a gallon at the highest. And then you can, you know, if you look at the bills and put them in a spreadsheet, able to track gallons, cost per gallon, you can see as it gets colder, our costs go up. It gets warmer, costs start coming down. And then you can see certain schools they're expensive. They're just way more expensive than other places. So those are some of the things I noticed.
I've noticed too in tracking diesel for use in buildings that you get a shipment of it that may be a day shipment, that may be a month, that may be a year shipment. It all depends upon what storage capacity you have and time of year. That makes it a lot more difficult from an energy tracking standpoint and allocating that energy out over weather and trying to make some sense of it. So that's always a challenge I've noticed. Whereas if you have, you know, electricity, it's billed monthly, a little bit more easy. It's more consistent to get that cost allocated out over those timeframes. So rate tariffs, demand charges, Empower and program changes. What's Empower, Adam?
I was trying not to talk today and let other people participate, but Empower Maryland is a program that everyone pays on their bills that's used to subsidize energy reduction projects in the state of Maryland.
Okay.
So we get our bills from Delmarva Power, but we're actually part of an energy co-op called ESMAC ET.
Yeah.
So Delmarva Power basically is the pipe, and you know we pay the supplier too.
Right.
Same with our gas bills. Everyone should have a copy of their tariffs to know why they're being billed what. And also sometimes you should review how your meters are being classed by your utility company because you might be classed wrong. That's a dual-edged sword though, I've found.
How your meters are being what?
They're being classed wrong. Like if there's anything any reason to separate the meters, try to consolidate these kind of things.
Yeah.
And we actually found at one site, if we consolidated the meters, it would increase the tariff and then we'd be charged more rate. But typically like outdoor lighting doesn't get demand charges. In our state, space heating doesn't appear to get demand charges on it. I'm pretty sure that might be universal though.
Yeah, I've seen with lighting, it's very common not to no demand charges, sometimes no energy charge, just a flat fee.
But I think a lot of people don't realize how much demand charges impact their energy bill when they use electricity, I should say, affects the rate. And I don't think most people know that.
Yeah, we're gonna talk a little bit about that when we get into the billing information. Halfway through the morning here. But it does have a big impact, and just as a underline of that, demand charges in general could make up around 40% of the cost of electricity. So
I see them get to be thousands of dollars all the time.
yeah, it's a lot.
Yeah.
It can be a lot. And that 40% probably varies around the country depending upon how they allocate out the rates between energy demand and other. So we'll be talking more about that.
Are we going to cover capacity tags? Because that's another aspect of this.
Capacity, what?
Capacity tags set your demand charges. Typically, they take, at least in our area, the 5 peaks, and then they use that to set capacity tags, which is timed by a predetermined rate.
Yeah,
There's so many moving pieces. It's nuts.
it is. And there's so many rate structures out there that you can't keep track of them. My experience has been with the rate structures in the Midwest, in particular Wisconsin, and that doesn't cover anywhere near what's out there. And this is the first time I've heard of that use of multiple peaks to conglomerate that and use that as a way to charge.
Yeah, I'll see if I can send you something on it, Ted, from SMAC.
That'd
I have
be
to see if
interesting.
it's confidential or not, but I'll send it to you.
Yeah. All right. Anybody else have some thoughts or comments about their utility bills that they had? They were to dig up. Was everybody able to dig up their utility bills? It's another good question.
Yeah, Damian Hill.
Maybe
I'm up here in Alaska also. Just very interesting stuff. One village, $1.60 a kilowatt hour. We're running off of diesel. And $10 a gallon for diesel. We have one village, actually, we have a hydroelectric plant that essentially runs 3 villages. I think the capacity is like 800 kilowatt hours, 800 kilowatts is the design.
Okay.
And so that drops it's 92 cents a kilowatt hour in the wintertime, and then 10 cents a kilowatt hour in the summertime when the electric boiler is running. And we sure could use it in the wintertime when people are actually in the school, because the river freezes up and we don't get any flow. So when we really need it, in the summertime, we don't really use any electricity in the school. So that's
Yeah,
just, go ahead.
Those type of numbers
Mhm.
just boggle my mind.
Yeah.
Damien, here in Wisconsin on a commercial rate, you're paid somewhere around 9, maybe 10 cents a kilowatt hour.
Yeah.
Equivalent. And that is a tenth of what you pay. So it's hard to fathom how to work with that. On the flip side of that, as somebody who wants people to save energy, it really helps drive that aspect home and makes projects in conservation very effective, very high return on investments. Not that that's
Absolutely.
helpful to you. I mean, your dollars are your dollars, and you don't have more of them just because of that fact, right?
Right.
But yeah,
I mean, every village is different. Some villages, like I said, we run off the recovery heat from the village power plants. So, if you look at our energy use index, and how much it's costing us, some villages it doesn't cost us anything at all because the village power plant is
yeah,
inefficient. So we get a lot of free heat.
yeah.
Um,
You were talking about that earlier in the season or a series, how that has an impact, and it's kind of nice it's inefficient, but kind of bad it's inefficient too.
right. And when the village power plants are becoming more efficient, we're getting less heat. So we're running our boilers more. It's a double-edged sword for all of this. And then integrating, we're starting to try to integrate some solar into the and renewables into the whole system. One village, we have 200 kilowatt wind turbines that hopefully are coming online, and that will run the entire village.
Yeah.
But the solar integration is another kind of funny thing. When we really need the solar, that's in the summertime when nobody's in the school, but in the wintertime we don't have any sun exposure. So
Yeah.
just my 2 cents to the conversation.
It's good. Well, it's interesting. You guys in Alaska have your issues with energy heightened because of those different extremes you have to work with. I see, Regina's talking about they have multiple providers. Adam mentioned that too. In different, because they have buildings in different areas. So you have to work with those different utilities to be able to understand them and figure out what quirks they have, because they all have a little bit different rate structures, and it makes it a little bit more difficult. So that's a challenge. It's a challenge. So also mention that there's going to be, they have time of use because solar is popular. We will cover time of use, and you're talking about the solar component. Now, I've thought about that just on a personal level with my own home and my solar, as to whether it's going to be beneficial to install some battery backup so that I could charge the batteries on a time of use rate when it's really cheap overnight, and then use solar during the day, or solar and backup during the day, rather than drawing from utility. That's a strategy that helps you cut your costs down. But the cost differential has to be there to accomplish that, which in my case it's not. Let's see what else here. Any other people find something on their utility bills that was of interest? And maybe just we really haven't talked anything about natural gas. Anybody find something on their using natural gas bill to look at?
I got something else. I mean, not something I discovered, just knowledge I have about it.
What did you
Bring
find
it on,
out?
Adam.
So our state recently changed how they're allowed to use the units of measurement in billing. And my AP department didn't realize that they can bill us in therms now and not only CCF. So the line moved one and they were giving me the wrong numbers. Also, if you use Energy Star Portfolio Manager, they changed the import template. They added a column for percentage of renewable gas that you're using. So all of my imports broke.
Yeah, there's all those quirks in trying to keep.
I mean, you don't get a notice when you log in that they did this or anything. You get a bunch of errors.
Yeah,
Looking for numbers, and I'm getting letters back because the columns don't match.
well, they probably sent out an email about it, but I don't know about you. I can't look at all my emails. So
Yeah, I mean, I've talked to them. I deal with them a lot, and they have limited resources. So they have a whole wish list of stuff they want to do, and they have to prioritize all of it.
yeah, it's difficult. And looking at utility bills is really important. Like Adam mentioned about how just some slight changes from the utility side can create issues for you. I had one come up, it was about a year and a half ago. No, it's just over a year ago, where the utility, for some reason, and I still don't know why, I think it just was a bad error on their part, decided to make the demand roughly 10 times higher than they've ever had in that building. And You know, in looking at it, it's like that building doesn't even have enough equipment to create the demand. It took me about 3/4 of a year to get that attention call to it. And by then, they were about $150,000 in debt, you might want to say, or paid too much, $150,000+ too much to utility as a result of it. And just those type of things can really drive you crazy. So understanding utility bills will help you catch items like that. Yeah, the mistakes typically aren't in your favor, are they? Or at least the ones we notice. So, any other last thoughts on that? Okay, so we're going to have a lot of discussion on utility bills, and we'll have to probably come back to this discussion here at a later point. But before we get to that, we're going to go on to our next topic, which is you collecting your data from your system. So Robert, I'm gonna let you take it over from here.
Awesome. Thank you, Ted. Just two quick things. One, if you haven't already signed in on the chat, please do so. We've got a couple people who I don't think have as of yet. Full name in the chat, just for our records. Also, if anybody has not gotten a link to their lab environment, please speak up in the chat so that I can get you a link if you need a fresh copy of it. It's the same link that you've been using the entire time, so if you still have that tab open or whatever, feel free to continue as you are. Okay? But we're going to jump into our lab environment real quick, and we're going to grab our historical power usage. Next slide, please, Ted.
Okay.
So when we do this, and I will give a quick demonstration here in just a second, and then we'll come back to the PowerPoint presentation. But we're going to use the export feature. Some systems will call it download, some will call it export, but it's pretty standard as far as spitting out a CSV type file, which is the most generic level of spreadsheet that you can get. We are going to be looking for our total power trend log, and we want to use a custom date range so that we are accessing absolutely as much of the historical data as we can. And the reason we're going back this far into 2020 is because of the date range, or the dates that the system was set up for when you first logged in. That way we are getting that information. I see your message there, Justin. I will get you a link here in just a moment. I'm going to take over the screen share here, Ted.
Yeah. There you go. All yours.
All righty, you should be seeing a mostly black screen with our regular information up on the left. Is that correct, Ted?
Yes.
Perfect. So I have just logged in. This is my default view. You will have your floor plan here in the middle, but we're going to go over to our tree on the left-hand side. We're going to open up our back 5K. We're going to open up our BOP T1. And then down here, second from the bottom, should be your total power trend log. Mine is looking like a wonderful downward slope for the last, 8 hours or so. To download this or export this, excuse me, we're going to right click here in the middle and we're going to export data. And again, we're just going to click on our custom range. Drop back to 2020. Grab it, leave it as the current time. This will be midnight this morning. Actually, I'm going to go back to midnight yesterday because, and would encourage you to do the same, because otherwise it may corrupt the data a little bit and you may not get the last couple of days. There we go. And for me, it downloaded to my downloads folder. Okay, easy as that to export it. We'll get into looking at it and using it here in a minute. Share, I'll go back to you, Ted.
Okay.
Let me grab, where'd my chat go? There it is. All right.
Hey,
Let me find.
we're gonna be bouncing around, just so everybody's aware, a little bit between screens and things, so I will be stopping my share, starting share a number of different times here. Just due to that. So one note to add on to your downloading of that data is you want to, this is really hard to remember to do. I'm guilty of not doing it myself many times, but I still want to try to encourage people to make sure they do something about it, is to document the data that you just downloaded. What is that a trend of? Rename the file to something meaningful. You know, in this case, you want to call it the energy data from the west side of Bob test or something like that. And possibly, and even put a date in there so you know what time frame it is. You know, what changes were made to your system that are reflected in that data. You want to look at the data to make sure that it makes sense. And we're going to be doing some of that here in a little bit, but well, actually after lunch, after noon, I mean. So you want to look at that to make sure it makes sense, and we'll find some things that'll not make sense in our data. You want to make some notes, and I suggest as much as possible you do it right in the data file that you just downloaded, so you have it right there handy. Or if you have another location that's good for you, go ahead and do it there. And then you want to take a look at the data. Is it continuous? In other words, if you have it set up for 1 minute increments, does it always go by 1 minute? Are there any gaps? Do you have a gap of a day somewhere or hour here or there? You want to check for that type of thing in your data. So it's always a matter of using your knowledge to sift through what you've collected and make sense of it and document what you have found.
And also there with information on continuous data, pay attention to your logging intervals. You know, this data that we downloaded is all at a 15-minute interval. So our systems are going to want to draw a straight line between those two 15-minute data points. But the truth is that it's rarely actually a straight line between those. We're just kind of interpreting and hoping that the flat line is close to the right answer. But the truth is, the longer the interval, the more likely that something weird or unique could be hiding in that data. So keep that in mind, that sometimes you need to adjust your logging interval to find those odd events that are happening. And particularly things like your peak load could be hiding in those time periods. So just something to keep in mind.
So our next section here, we're going to talk about meter data and get into that interval discussion a little bit more, and then get into utility bills. So meter data, the interval, Robert just did a pretty good job explaining that, and I'd want to add that this is something that's very important for us as technicians to realize how the interval we choose impacts the results we get. There is no such thing as a continuous set of data. There's always time between it, because what happens is the system says, I want to know what that reading is right now, what that number is right now. It goes out and it grabs that piece of data, brings it back. Well, it's just that second that it grabs it, that instant it grabs the data is the number it's getting. So it can change the next instant. And that often happens. And so if you're trying to capture something that's very quick, you have to make sure you have your interval set up so that it can capture it. And that makes a lot of difference. A 15-minute interval is not going to catch a anomaly such as a motor starting to see what type of spike you get on it. So you have to make adjustments to what your intervals are in order to capture those type of things. And so we're going to, in the next couple of slides, talk about monthly. We'll cover a little bit about 15-minute. Anybody know why we want to use 15-minute data? That happens to be a very good one. It kind of gets into our billing discussion here in a little bit. Robert, you know why?
No, I think you hit that one.
What is that?
I think you got that one nailed down just right. But do keep in mind that this principle doesn't apply just to energy data. This applies to any data that you're trend logging. That anomaly may be hiding in between the dots. So always be thinking about what happens between those intervals. Motors starting, motors stopping, dampers could be oscillating, or valves could be oscillating. Your variable frequency drive could be hunting. And that 15-minute or 5-minute or even 1-minute interval data may not show that. So it may also be something that you kind of have to go and manually watch to see what's going on. We want to avoid that as much as possible, find the issues with the trend log, then go and spend the bulk of your time on the troubleshooting issues of importance.
Yeah, so it seems like a mundane thing to think about intervals, but it can be really, really important for getting the information you need to make adjustments with. So,
And Adam does remind us in the chat that make sure that you have enough memory to do this, especially for those of you who I know are running older systems or more limited systems as far as resources go. Make sure your system can handle that more frequent trend log data if you are going to change the intervals. Be very careful with that.
yeah, and that is not as much of an issue as it used to be.
True.
But because we're getting controllers with bigger and bigger capacity all the time.
But
I've done a
the
lot.
older controllers don't overwrite. They just die when the memory fills up. I learned that the hard way. They just stop. It's not like,
That-
hey, I'm gonna look at the oldest entries and start. No, they just die.
Yeah, that depends on
Yeah.
your controller.
It does,
Some of
but I
the
mean,
old
it is a
ones will
possibility
roll
to be
through.
aware of.
Yep.
Yeah. Well, that's a nice thing about upgrading. You get things that have better capacity. And that's true with all the devices we use for tracking what we do. All right. We'll move on to the next slide. Continue on metering data. From utility meters, and here we have a picture of a rotary gas meter. This one actually happens to be on the side of the building I teach in. And I use this every fall semester when talking about billing and grabbing information, how the utility takes it, so that the students get a handle on how to read their own meters. So they start to understand a little bit about this finite nature of that number they grab. So utility meters are typically read monthly for invoicing purposes. And that month might be 20 days, it might be 31 days, 36 days. It just all depends upon their schedule, how they do it. Over the years, it's gotten more and more that a meter is read on a certain date of the month. And it's read that date of month every month, so you can count on it. With electronic meter reading, that's more of a reliable thing. Back when I first started in this industry, I worked for a utility, and it was the meter readers going out with a flip pad on a ring for every meter, and they would have to write the information out. And that just, for one, because of people being sick, holidays, things like that, meant that you never got a meter reading on a consistent day of the month. And that has been the way it's been for quite a few years, until it started getting a little bit better in the 90s when some electronic meter reading came up. And now here in 2025, a large majority of meters are actually read electronically, so it's not as big of an issue. In fact, a lot of meters are read not just remotely, but they're picked up from a central site on a regular basis. When a lot of the electronic meter reading came into play, there was actually a van that had to drive around and get close enough to the meter to be able to pull the data, and that's not even true anymore. So the other thing, we talked about the interval data. Well, utilities can provide more detail on their information, because the electronic data comes to them oftentimes at 15-minute. Sometimes they can nail it down to 1-minute intervals. I don't know, Robert, what have you seen on that?
I've rarely seen a utility that will give data more frequently than 15 minutes. And
Okay.
usually to get that level of interval data, you have to either request it specifically from the utility. You may need data all the way down to the meter number to be able to get that information. Or some, or a lot, seem to have changed over to providing access to that through an online portal.
Yeah.
Sometimes that's a advertised thing that you can do through your regular portal. Sometimes it's kind of one of those deep, dark secrets that you have to know the secret handshake to be able to get to, or you may have to use a proprietary application of some kind to make that connection and get that data. But most utilities that I've seen, especially on the electrical side, have that data that they can provide. I've not seen it nearly as frequently with gas or water utilities.
Yeah, that's been my experience too, especially where they readily provide the monthly readings on your bills, and you have to take another step to get more detail. And that's always been the case, but some utilities, they provide a pretty good service of giving you the information on 15-minute intervals, and they'll give you heat maps of when you're using that energy, so you can get a better handle on things you might be able to do to reduce your consumption too. Okay, we'll move on to the next slide. So we just talked about utility data, utility meters, and how you go out and you have to read it's one reading every month, typically, with the electronic stuff, allowing it to go as far down as 15 minutes, some cases 1-minute interval data. And then just keep in mind this, again, it's all, it goes, grabs a point of data, brings it back and stores it. And then the next interval, it goes, grabs that point data, and brings it back and stores it. We do the same thing when we as owners go and set up meters. And so, Robert, you want to talk through this?
Absolutely. So more and more, I'm sure you're seeing it. I've been seeing it for years now. But owners are deciding to install additional metering because it provides better or more granular data, easier to access data. It can report right into the systems that we already have instead of having to go pull it out of the utility. And it allows us to break down that big chunk of data. We've got one electric meter for the building. Okay, well, what if I want to know how much my mechanical equipment is using versus my lighting loads versus my plug loads? Our owner installed meters give us the ability to get down to that level of granularity. You can even get down so far as to per pieces of equipment if you want to go to that level. Our modern smart electrical meters are so affordable now and so capable that things like that become much more practical. With things like our motors and our that are on variable frequency drives, and big equipment like our chillers, maybe factory controlled rooftop units. Some of those can also provide some of that data. It's usually not as comprehensive as what you get out of an smart electric meter, but it may be enough so that you don't have to spend that extra money. That being said, it's still data that you have to figure out or have some contractor set up for you to go and acquire. But almost all variable frequency drives that are still surviving in your building probably have this capability. Of course, we don't just install electric meters. We can install BTU meters. If you want to log how much energy the heating or cooling is providing to one floor or one building, if you've got a central plant, BTU meters are definitely an option. They come in a lot of varieties. You can get anything from that, go and read the meter manually once a month, to all the way up to the smart meters that can give you gallons per hour or gallons per minute, and all of your temperatures so that you can follow through and see the exact calculations that it's doing. And just like with utilities, we have gas and water meters that we can install as well. These are not, in my experience, nearly as advanced as what we're seeing on the electrical meter side. They're much more basic. Occasionally, you'll see somebody put in a flow meter like you would find as part of a BTU meter, but most of the time that's more expensive than most people are interested in doing. So you get really basic, just totalized readings of gallons or CCF. And you have to go through some sort of a converter that'll actually then tie into the system, either providing the data via BACnet or Modbus or some other communication protocol.
Yeah, and the reason that they tend to be a lot simpler as far as the type of data they get you is because it's a much simpler utility. With electricity, we have all these different rate structures, different needs. And with a gas meter, you don't have that typically. And even if you do, it's nowhere near as complicated as an electric meter. So there's logic behind why they tend to be a lot more simplistic. And on the water side, it's even more that way. In addition, water utilities tend to be more localized, municipality type of setups, and they don't have the capacity to be able to get into all these really fancy type of rate structures, I'll call them, or very detailed rate structures. So there's a reason for that there. The other thing I was thinking about, and we kind of talking about with this, is when you're setting up what metering you have to know why you want that meter. And you have to, based on that, define the information you want to get out of it. And that's really important. I'll give you an example where I've had to do monitoring of different types of air conditioning equipment, primarily rooftop units, over a period of 4 years. And the customer had wanted me to measure all that in terms of KW, KWH, on and off peak, and power factor, all those types of things. And I kind of coached them that, okay, we'll do that with a couple, because we're talking close to 100 different units over 4 years of monitoring. And I coached that at the time, we didn't want to necessarily do that detail for everything, because the equipment was such that it wasn't necessary to know the exact KW at any given time, as long as we could take a spot measurement of power factor and voltage at a couple different points of operation and apply that to an amp reading we were getting, which is much more simple and easier to grab the data on than power metering, we could significantly cut the cost of the monitoring project, which would hold the same for you. If you're looking at different things you need to meter, you got to find out what's really important. In our case, the exact KW wasn't the critical factor. It was overall impact on a percentage basis that really made a difference. And therefore, having the exact KW at a given time didn't matter. Just the relative number that a amp reading gave us was adequate. And so you have to think about that when you're doing your metering in the same way. Think about what you really want it for, how that sets up your intervals, and the level of accuracy you really need. Because those all play into your cost and complexity of your own time in dealing with it. Robert, any other thoughts on that?
No, I think that really sums it up really nicely, Ted.
Okay. Now we're going to get into utility bills. Utility bills is a topic that, you know, you could take and spend hours and hours talking about and learning about, or you can just get one number off it and run off. We have a limited amount of time that we can talk about today, and I think I might even condense it a little bit so we have more time to actually work on manipulating things in spreadsheets. But this is a typical utility bill for electricity in my area that you see on the screen right now. I'm going to throw it out there. Everybody that was able to find the utility bill for your facility, maybe just throw in a chat. Did yours look as complicated as this, or less complicated, or more complicated? Just go ahead and throw it in, or open up your mic and tell us all. This one here isn't as complicated as the ones I've seen. So Jessica says hers is pretty much the same level of complexity. There's a lot of information on this sheet. So Adam's saying his are more consolidated on one page. This actually is one page too.
I mean, yours are more consolidated. Mine are 5 pages.
Oh, 5 pages?
Yeah.
Oh.
So these graphs and stuff aren't on the same thing as these demand charges and all that. They're separate pages. I don't also think I get the temperatures and stuff.
Yeah. Yeah, there's a lot of good information on this, and it's more consolidated. They used to provide a lot more detail, and sometimes I think that just makes it a lot more difficult to understand and work with. Just so you know that each state has their own public service commission that regulates how utilities can charge you. And over time, they've tried to be more transparent in what they're doing. And that has caused these bills get more and more complicated over time. And so if you're looking at this going, why do you have to have all this breakout? What is all this stuff? Well, it's there so that the Public Service Commission can work with utility to do a better job at allocating out the costs that you are charged. That's the bottom line for it. Does anybody have much simpler looking bills? Electricity is going to be the one that's going to be the most complicated, as we mentioned before, too. So, all right. So on your utility bills, I'm going to open this up to everybody. what's important for you to see on your utility bill? Is there anything in particular? And if you had one thing you want to see from your utility bill, what is it?
Usage, most important for me.
Use as like energy usage.
And then we go to demand second. Cost, I know it's gonna get paid one way or another, so
Yeah.
I try not to look at that because it makes me depressed.
Well, in all my years of working with this, as an engineer, cost is secondary to me. I'm more interested in the energy demand aspect to see how much it is, and also to start thinking about ways I can reduce it. Anybody else have an idea what they look for? Maybe Nina or Gina or Lindsay or Jean? Having a
Yeah,
hard time telling? Go ahead, Jean.
yeah, good morning. I like,
Oh, you dropped off there. Maybe you can put it in the chat. Because for some reason we're not hearing you. Anybody else have anything? Carlos, Dan? All right, well, we'll move on from that. We'll go on to the next slide, which gets into this a little bit more. So why is it important to understand your utility bills? Well, first of all, it has to be paid. So understanding it will allow you to understand why you're paying the dollar amounts that you are. The accurate application of your costs, if you're looking at doing some calculations for energy savings, or just to determine, say, a new piece of equipment you want to install, what's it going to cost you, is important. And so understanding how your bill allows you to do a better job of managing that cost. So without understanding it, you probably will end up costing yourself more money, because there's some things you can do to shift how you use your energy to save money. We talked about one of them, time of use rates, earlier. So that tends to be a very critical thing. Let me see here. So I guess we'll go on to the next slide. Part of understanding your cost is understanding how you use your energy. This will get us into a little bit of discussion about demand versus energy. But this is a quote unquote typical profile. Our local utility has provided this as a way to explain utility bills and your consumption patterns. And you can see that they have demand on the left, time on the bottom, the x-axis. And any given point during the day, you can see what the demand is for your facility. We're going to actually, well, get to the point where we're going to see this type of thing for your data you just downloaded today. We'll plot it out and you'll get to see that. It won't look quite as clean as this, but it'll give you the idea. So as overnight, the use is low electrically, and then people start coming into the building, turning things on, and the consumption goes up and up and up until sometime around lunch or so, a little bit after lunch, energy consumption peaks. And then middle of the afternoon or so, it starts to decrease, keeps on decreasing till after supper. And in this case, by midnight, it's back down to a normal overtime night peak. Every building's different. Every building has a different profile. Regions have different profiles. Matter of fact, for Wisconsin, I'm not sure if this one really even holds anymore. But it's very, very good way of thinking about your energy. And you know how we talked about when we're metering, we grab a point. Well, you see this peak here, that's 1 point. It's a 15-minute interval. In Wisconsin, we're always looking at 15-minute intervals for billing demand. And that's pretty common throughout the United States. It's rare when it's not. So that 15-minute interval is the way that we're gathering, as a utility, they're gathering information to charge you off of. Each one of these 15-minute intervals is a kW, but you add those all up over the course of the day, and that equals the consumption, or kilowatt hours. So everything underneath this curve is your consumption, kilowatt hours. So if we have 15-minute intervals throughout the full day that we're measuring this, we would have 24 hours times 4 15-minute intervals during the day, or during an hour. And I'm sorry, I'm going to have to do my calculator on this. It should be about 96, right? Yeah, 96 intervals during the course of the day that we are taking readings. Well, whatever all these kW added up over the full day, divide that by 4, because kilowatt hours is, there's 15 minutes in an hour, divided by 4, so you get your kilowatt hours. And that'll give you your use during the course of the day. So how many people understand calculus? Anybody?
I do.
You do? Good. Is that you, Robert?
Yeah, of course it was.
That's been a long time. Okay.
Yep.
Says, Robert and I having this discussion this morning about how, he has more detailed memory of things that he learned in calculus class than I did. For me, it's kind of all information that's in the background. But this graph is calculus. We have the actual points. That's the one part of calculus, is the proportional part. Then if you integrate each of these points over the full day, that gives you your area underneath this curve for consumption. So you already understand calculus now. That's 2 major components of calculus is covered by this graph. And actually a third one would be, how fast is it rising or going back down? That's the third component. Proportional, integral, differential. Things we deal with in the control world all the time.
Derivative. Not
Derivative,
differential.
I'm sorry. Yeah. I always mix those two up. See, I told you he remembers more than I do. So we'll go on the next slide. When you break out your utility bills, we mentioned this earlier. I did one. I think it was that one I showed at the beginning of these slides here. Energy part of it, your usage, that was 50% of that particular bill. Demand ended up being 48%, so even higher than I mentioned before. That varies depending upon the time of the year, but it gives you an idea. Other charges, 2%. This breakdown is from a facility that spends about $220,000 a year on electricity. So it's a pretty average type of facility here in the States. That's probably 100,000 or 200,000 square feet space. But we talk about these things: energy, demand, other charges, and that gets us into some billing terms. Oops, you know what? I want to go back. I'm sorry. Gets us into what are these things really? So if we think about it, let's use an analogy of an automobile. The gasoline that you put into your tank, or the kilowatt hours that you charge your car with, that's your energy use. Your engine has a certain horsepower maximum it can generate, but at any given time you're driving it, you're using a different amount of horsepower. And so that gets into this type of graph here where you're looking at it, and sometimes you're going all out, sometimes you're just coasting. So that's that horsepower component that we get into. Then these other charges, those are for things like your driver's license, your car license. I think, Robert, you had some other in there. Oh, that's right. Maintenance cost is also part of this breakdown here. It's part of our energy and demand cost, but it's typically not in your other charges. So does that help explain a little bit about demand and energy, the differences between them for people? Anybody have some other thoughts on how they like to look at it? All right, well, let's move on. That gets us more into the billing terms itself. So we mentioned time of use already. With utilities, we have a charge and costs associated with all different components that vary depending upon the time of day. During the daytime, consumption or draw on the utility itself tends to be very high. Overnight, it goes down low. But the utility has a lot of fixed costs associated with their power plants, their wiring, all their distribution, personnel, that is there during the day as well as night. So high and low periods that they have to allocate out. So at night, there's less of ability for them to cut back on their power generation with the old forms of power generation, which are coal-fired, to a lesser extent, natural gas, maybe hydro. If you have some renewables they're generating overnight, they're generating that electricity. They can't always cut it back, but they need to get rid of it. So they want to put it out there and have you use it at a lower cost so that you do use it. And that's why they set up these time of use rates, so that it reflects those low use periods when they need to get rid of energy. So they provide a lower cost to you. But during the high use periods, when it's really expensive, they have to bring on their peaker plants, which cost more money to operate. And they want to be able to allocate those costs out to those people using it during that time frame. So that's the basis for time of use. The same type of thing applies to not just daily changes, but seasonal changes, say summer, fall, winter. I've seen different types of rate structures around the United States that have multiple peak use periods. So you might have a shoulder period, you might have a midterm or mid-peak, peak, off-peak, all these different types of terms that come into play for how you're charged. And this primarily is related to electrical billing information. Anybody have any other terms? Just go ahead and throw them in the chat as I continue to talk about the PGA and things like that. Another way that utilities allocate out costs is they have power plants that are there as part of that fixed cost. And they have some they had mentioned before where they have to bring them on for peak use periods. They also contract to buy electricity or buy natural gas from other places, so that when there's high demand, they have to use those contracts that might be at a higher cost, and they have to be able to allocate for it. If you have a lot of really hot days in the summer and they're using more of those expensive sources for energy, they need to be able to charge the customer for that. They can't necessarily eat that because in the United States, we do have, they're regulated monopolies that they have to be able to make up their costs. We don't want them to go out of business. So they have to have some method of allocating that out. And that's what's in the PGA, which is a purchase gas adjustment, or PCA, or purchase cost adjustment. And just mentioned in chat, there's environmental surcharges also. So that could possibly apply to things such as having to use dirtier plants. By dirtier plants, I mean plants that generate more pollutants than other plants that have to be accounted for. So there's these different mechanisms that utilities use to account for cost structure, and that's what adds to the complexity of your bills at the end of the month. There's another component in billing terms that's talked about. It's the reactive, or KVA, or KVAH cost, which I kind of lump into power factor cost. And that's allocating for the fact that we use the kilowatts, which is the power that we get that actually does the work. But there's another component to electricity that we have to have it there. It energizes coils and energizes the coils, say, in a motor. It's a reactive component that doesn't directly do work for us, but we have to have it because without it, we can't do what we need to do. That comes through. The utility actually ends up paying for that in their generation. They have to be able to allocate that charge somehow. On small meters, it's not worth the extra metering components involved and complexity of it for them to charge directly for it. So they just kind of lump everything into a kilowatt hour cost. But on larger meters, like the majority of buildings that we work with, there is an adjustment made based upon how much reactive energy a customer uses. For the accounts that I currently have, that adjustments in terms of power factor, that makes adjustment to their billed demand based on power factor deviating from 85.85 or 85%. So it is accounted for, it's in there, it's something you will see on your billing in some way, shape, or form. And actually, like the bill I showed earlier, it doesn't directly show on the bill, but if you go into the rate structures, it'll tell you that it's adjusting the demand based upon power factor. Adam called out this other thing for degree days. He said that it's interesting on the bill that I showed, it showed not just degree days, but also temperature. The utility's trying to give you a gauge of how hot or cold it is outside. Anybody know why that might be important?
Weather normalization.
Weather normalization. That's right. Because if we look at our bill, are we going to think differently about our consumption on an electric bill in the winter versus the summer as to what's driving that consumption pattern? And the answer is yes. If it's hotter weather outside, we're going to expect to see more cooling energy, and that's being supplied or noticed on our electric bills by kilowatt hours and kilowatts. We're going to tend to have higher demand, and we're going to tend to have higher kilowatt hours. If we're doing a lot of electric resistance heat, like I've heard a number of people talk about already here, that electric resistance heat is going to be used more in the winter months, and you'll see that started to raise your electric bills. And so this weather component, higher degree days, higher temperatures, lower degree days, all how it plays into our uses, our consumption patterns can give us a feel for that. And then when we actually get to it later on, we'll talk about a little bit about energy tracking. It becomes critical in us to track our energy consumption, to track also weather, so we can get a feel for what's happening with it. So those are some of the terms that we have in billing, and some other ones that we come up with there, and then you'll see them. And actually, I'm gonna go back a couple slides because it'll
Before
help
you
us.
do, Ted, I've
What's
got,
that?
before you go back too far, I've got a contribution on power factor as well.
Okay, go for it.
So the way I've seen it, in more rural areas is they make it a penalty on your bill. And oftentimes it is a very significant penalty. And we don't see it nearly as much with commercial buildings as we used to. The old fluorescent lights that used big transformers instead of the modern electronic ballasts were a big culprit in that for your average commercial building. Nowadays, most of the time, the places that run into those issues are much more likely going to have a lot of heavy motor usage. So a lot of industrial, like manufacturing type things. So it's become significantly less of an issue for us on the commercial side, but it is definitely something to still be aware of, because if you cross that boundary, it can get expensive very quickly. It is not hard to alleviate that problem either. So if you're seeing those type of charges, I would highly encourage calling an electrical engineer to help you resolve those, because it really is not an expensive fix to make.
Yeah, you just need to install some capacitors to be able to work with that. And it's also true that a lot of our equipment that we're going to today tends to correct power factor just due to the fact that we're taking AC, converting it to DC, and using that, it automatically tends to bring that power factor up. So there's just a lot of things we're doing. Electronics, like you mentioned, electronic ballast and fluorescent lighting, VFD drives on motors. All of our electronics that we're trying to plug in today just tend to be a lot more higher power factor than the equipment we used to use in the past. So, all right. What other terms? So on our bills, we're going to have KW for demand. We're going to have KWH for energy. On the gas side, we're going to have therms or CCF or MCF. Therms are basically 100,000 BTUs of natural gas. That's the definition of them. And we're really not measuring therms at the meter. We're measuring a volume of gas that comes through. And so they sometimes will base the charge on CCF, or hundreds of cubic feet, or MCF, thousands of cubic feet. Then they have to apply a factor that says, okay, for each cubic foot of natural gas, there's so many BTUs in it. And that factor typically is about a factor of 1 plus or minus 5%. I've been seeing 1.05, 1.06 applied to the gas that I've been getting lately. But I've seen it vary a little bit from somewhere in the upper 0.9 something to the 1.06 or 1.07 that we seem to currently be seeing. So there's adjustment to it. So there's all these different things that go into your utility billing.
That adjustment factor will also be affected by the pressure that it's measured at the meter too, won't it, Ted?
Yeah, and so that's adjusting the CCF part of it. So there's actually two different adjustments that are made. Actually three different adjustments that are made. One of them is temperature. In the dead of winter in Alaska or Wisconsin, that gas is coming through pretty cold. But the term CCF is upon somewhere around 70 degrees Fahrenheit, 1 cubic foot of gas at, I think, atmospheric, but I'm not positive. So it's at a given temperature and a given pressure that we're supposed to be measuring that gas. But the real world is that you're not always getting at that. You're getting at some other temperature and some other pressure for instance, the natural gas coming into my home is coming off the street at 30 pounds. Before it goes into my gas meter, they drop it down to inches. And the gas meter is measuring in inches. So they have to make all these adjustments to the amount of gas volume wise that they're measuring, that temperature and pressure has to be adjusted out. Now that they have it adjusted to a normal cubic foot volume, they then have to go, okay, per cubic foot, we usually see this many BTUs, but we're basing that cubic foot off of 1,000 BTUs per cubic foot. So they have to make that adjustment with that second ratio or third ratio, depending on how you look at it. So yeah, there's many factors that go into measuring that. I think all my screaming I did, or talking loud last week, and it's still coming back and hitting me. My voice is starting to go. Let me see. Then, you know, water, sewer, fire protection has its own language, and a lot of different terms come into play when you're looking at those bills that I'm not going to get into any detail here, but just be aware that it's much different for several reasons. One being that the entities providing that resource to you don't have as much of a need to be as detailed as, say, a electric utility or gas utility. So, all right, moving on. Why is all this even important? Well, when we're looking at projects, we're trying to find out how much energy and cost that energy is being used. We need to be allocated properly. If we are looking at a lighting project, let's say for a school, that lighting project in the school, those lights are going to be in a classroom during normal operating hours. If we look at our time of use rates, time of use, one example of that is from 9 a.m. to 9 p.m. is on peak energy time. Or our lights in our classrooms are on mostly during that on peak period. Some of it in off peak, but most on peak. So we want to be able to attribute any energy savings to that on peak energy cost. Well, you can see on our bill here, and it's kind of hard to read this, and I apologize when the particular slide I wanted to find, I couldn't find it. So this is an older one. It's kind of blurry. But you can see on here, on our bill, we have all these different charges. We have a customer charge, and that's for demand. We have an on-peak demand charge. That's the one that our local utility calls billed demand charge, and that's the one that's adjusted for power factor. We have these different legislation requirements that are applied, and a facilities cost. We have a state low income assistance fee, which that pays for things like weatherization and stuff like that, and also helps to pay for our formal demand side management program here in Wisconsin. There's a tax cut credit on this one. I think this bill is a little bit old. It's from 2018, so it's no longer on our bills. There's off-peak and on-peak, and the on-peak period is weekdays from 9 to 9 for the majority of the customers in this utility's service territory. That means that from 9 at night till 9 in the morning, it's off-peak. And weekends, it's all off-peak. So when you look at your bill, you automatically can go, okay, if I see my off-peak increasing, then I know I need to look at what's happening during my off-peak hours versus my on-peak hours to go and find a problem and hopefully be able to correct it. And this gets into looking at energy tracking. You want to get the detail into your energy tracking that allows you to do just that. There's a fuel cost adjustment on peak and off peak. But what you'll notice here is we have charges associated with kW, charges associated with kWh, and then these others that are associated with either days or just a flat fee. And that harkens back to a couple of slides ago when I talked about we're looking at energy, demand, and other charges. That's how that bill is broken out. We have energy, which is off and on peak kilowatt hours here. Demand, two different components on this bill. Sounds like what Adam has might even be more than that. And then we have these other costs which aren't associated with energy or demand. We want to be able to differentiate those and apply it to whatever energy conservation method or not method, but project we're doing. Because something that hits demand, but really doesn't impact energy, we want to just attack the demand charges and use those as part of our cost analysis. That makes sense? Anybody have any questions on that? All right, we'll move into the next area. This gets back to, I forget why it was raised, but somebody's talking about the different parts of the bill and looking at, I thought it was days, but we'll see here with this. This is part of the bill that I showed you earlier, and it shows you have billing days in the period. You can see it changes. When we're tracking our energy, we want this all normalized to a given calendar month, or maybe 30-day period, depending upon how you're looking at it. The average temperature during that period, heating degree days, and cooling degree days. Well, this is in February and January, so we only have heating degree days on this one. Now, heating degree days, that's calculated by looking at what the average outside temperature is that day compared to 65 degrees. The difference between that, if the average temperature is lower than 65, that difference is going to be heated degree days. If it's higher than 65, that difference is going to be cooling degree days. They don't cancel each other out. What we do is every time it's lower than 65 degrees, it goes into heating degree days here. Every time that it's higher than 65 degrees, it goes into cooling degree days. And it's just a bucket. We do this day every day. That calculation is done and added up for the whole time between meter readings. And that's how we make a gauge as to how hot or cold it is and what type of impact that has on our building. Now, I've looked at hundreds and hundreds and hundreds of meters and buildings in modeling energy consumption. 65 degrees is not normal for a commercial building. In the schools that I've looked at, the balance point, it might be as high as 60 degrees. It's rare when it's as high as 65 degrees, but it could be as low as 50 degrees. It just all depends upon that building and that meter, what it's all serving. So that the reason I'm bringing it harkens back to, why are we using 65 degrees? Well, we have to have some basis to get a gauge on this. And degree days was developed back in the 70s. I believe it was 70s. It was in place as a result of modeling, energy modeling that was done by utilities to determine heat loss and gain from buildings and the impact with solar thermal heating. So what they found in residential buildings, that 65 degree was more often than not an average type of a balance point for a building. And so they stuck with that just to keep everything consistent. Now, if you're in agriculture, you'll have degree days for different reasons. You have them for the growing season. And they use different temperatures for that because the growing season temperature is much different than what we use for space heating and cooling. I forget, my buddy, he's in the barley industry and helps funnel money to research for all that. And he always talked about the barley degree days. And I forget what the base is for that, but it wasn't 65 degrees. Other important components on this invoice that you see are the intervals readings. This on your bill, and does anybody not see the readings at a given date on their bills? I'd be curious to know if somebody doesn't see that on their bills. And it's just that they don't give you the time to read it. Anybody not see it?
Or has anybody seen where they have one of those meters being, or those numbers being an estimated number?
Oh, it's going to be getting into it. Yeah, that's important. And that's why, I was going to start driving into why this is important, because this can be and what I find today to be the most important thing to get you to the point of finding out that there's a problem in your bill. When the meter is either estimated or changed, they change out a meter, that's going to be a point of error in your billing information. The estimated readings on the energy standpoint aren't overly critical because the next month they get an actual reading and it adjusts itself. But when you get a meter change and they accidentally put in the wrong number, there's no adjustment.
Or
So
the wrong multiplier,
what was that?
or a wrong multiplier if they change
wrong
from
multiplier.
a
Yeah, I forgot about
meter
that.
that has like times 10 to times 1 or times 100. Really
And you
ugly
see here-
results.
On this one, the multiplier is 800. Another meter I looked at recently had a multiplier of 60 on it. So making sure you get the right multiplier is a very, very important thing. And again, that's something that can happen when the meter's changed. If they just leave the old multiplier in there and put in a meter that doesn't have that same multiplier, well, then you got a problem. So this is an area where you can look at it, but the important part of this is it's the date the meter's read. And we're just looking between 2 points. It's that interval we talked about earlier, where they're grabbing that point 1 month. Then the next month they go in and grab that point again. And the difference of the accumulated information gives you the usage for that month. Other things that are on your bill, it will tell you the rate structure you're on. I can go to this particular utilities, it's We Energies. I can go to their website, find their rate structures, and look up this one and find out how I'm being billed. The meter number is the actual meter that's providing this information. And that's important only when there's problems or when you're trying to figure out which meter is doing what. But that's important information to have.
And I think Adam was the one who brought it up earlier, but make sure that take a look at that rate structure and make sure that it's appropriate for that building or whatever that meter is being used for. Because being on the wrong rate structure can very easily mean you're just throwing money right down the drain. I fought this with when I was managing the bills for the college I worked at, especially on yard water, or irrigation water is what they called it. So the water that we use to water the grass and everything like that. And the big issue with it was that for that municipality, that didn't get charged sewer usage, which was almost equivalent to the cost of the water itself. So by getting it on the correct rate structure, we almost halved a whole set of bills.
And it's something that's important. So the other comment here, it says message, they actually had a message on this bill. It says KWH consumption is billed using 15 minutes interval electronic pulse data. So that pulse data is grabbing that point every 15 minutes. And they add up all four for an hour, divide that by 4, so you get an average KW for the hour. So it's KW over 1 hour, kilowatt hours. And then they do that for every time frame between the meter readings. These windows for 15 minutes, different utilities use different types of windows. Here in Wisconsin, the one I've seen is they will start at a specific time. I'll say at 9 o'clock, it starts. And then 9:15, it ends for that time. So they take a reading. Then not at 9:30, take another reading. 9:45, another reading. So they keep on doing that. There are other utilities that will use a sliding window. So they may take readings more frequently and just have a sliding 15-minute window and take the average of that 15-minute readings and use that number so that they can better represent what their use is. So there's utilities use different methods, but the primary one that I have seen is they take a reading every 15 minutes on the hour and quarter hour increments. Yeah, Adam made some comment about light reading for rate structures. Those rate structures get into some very legalese type of discussions, determining your rates. And they're not fun reading. But after you've seen quite a few of them, it starts to make sense. 200 pages for the one rate structure he has. It's a tariff book that probably covers a lot of different rates. So it can be daunting. But us as building operators, we don't have to get into all that detail. I'm providing you more detail you probably need right now, but that's so you can go back and you can start to figure out what detail you need to apply to what you're doing day in, day out. And then you'll have a better understanding and ability to do a good job at it. So now I'm going to get a little discussion here on energy tracking and different sources for doing it. The main part of energy tracking is you cannot manage what you don't measure. So if we're trying to control our energy consumption, we have to track it. We need that feedback mechanism. It's like with our controls. When you have controls, you have open loop and closed loop controls. We prefer, if you're looking at energy, trying to get it down, you have a closed loop or energy tracking mechanism to give you feedback on how good your projects have done. And that's why energy tracking can be really important. Now, being somebody who's operating a building, most of us aren't going to get involved with energy tracking other than somebody else, maybe back at the central office, might be providing us that information so that we can make some adjustments to try to cut back on consumption. But there's different methods that we use to track energy, and having this billing background that we just went through is really important to be able to track your consumption. I prefer that you're tracking as many of the components on your billing, you know, consumption and demand, as possible, so you can better control what you're doing. I'll give you an example. With most of the meters I've monitored and tracked over the years, we look at on peak and off peak for the energy side. And then we look at for demand, the on peak bill demand, which is between that 9 and 9 period, and customer demand, which I didn't explain customer demand before, but I'll explain it now. There's a demand structure out there that is often referred to as a ratchet. In other words, customer demand for our utility is based upon the highest demand created in the past 12-month period, no matter what time of day. So this is a peak demand you have during the course of a year. And that cost sticks with you for that whole time period. And let me see if I can see it on the bill we had. And I'll be able to show you. It will tell us, it should tell us. If we look at this here, our whole customer charge, it should show us where the customer demand is. So customer demand was created on September 5th of 2023 on this bill at 7:45 in the morning. And it was 876. So this is a school building, and I forget whether it's a high school or middle school. And it's probably a high school at 876 kW. It created its peak demand at that time and date. Well, this makes sense. School just started back up. They probably had a hot day that one time during that month, and that created a need for air conditioning. They still had air conditioning available, so they turned it on. And as a result, they created a peak demand. But this billing period is only between the dates of January 29th of 24 and February 27th of 24. So you can see that this is what we call that ratchet customer demand that's looking back at the highest demand in the past 12 months, and they're being charged at the rate of $3 per kilowatt for customer demand every month. So that 876 kW times $3, costing them almost $2,700 every month for a full year, or until another higher demand is created. So that's why, you know, paying attention to demand is important. It's really important for on-peak, but to a lesser extent, it's important for off-peak also. You want to make sure that you minimize that number also, because this demand, this charge, ends up being equivalent to about what, and in this case, it's even more, what the on-peak is for a month or two. So you've got to pay attention to that. Go back here, take a little bit to click back. Robert, in the meantime, you think of anything else I need to cover here?
No, I really think you hit all of it.
Okay.
We call out Energy Star Portfolio Manager as one of the ways to track energy, because it's to this point been free to use. And, you know, I know since everybody here is running schools, a lot of times you'll run into an opportunity for grants and things like that. And historically, one of the things that was required as a something you had to do prior to application or as part of the application was to have a certain amount of utility data for whatever building it was stored in Energy Star Portfolio Manager. It is by far not the only one out there. There are well over a dozen other options for this as pre-built options. And there are also homegrown options. There's always the classic spreadsheet or in-house database that can be done as well. So just one method.
Yeah, Energy Star is by far the most recognized, and I think it's by far the most utilized tracking service, in part because it's free, in part because it's central to many different conservation programs out there for obtaining funds or loans. And it also plays into a lot of the benchmarking required for different municipalities, cities, and states. So it's critical for those aspects. And you know, Lindsay's pointing out that it may go away after October this year. So that's something that we need to think about. Something about me just says I don't think it will, because so many people utilize it, so many people rely on it. But I've been surprised many times, so I guess I might be surprised with this one too. We'll see. Again, I really feel the more detailed, the better the information, and the better you're able to keep track and keep your energy consumption down. That's my 2 cents of it. What's critical with these is that you are looking at putting in your on peak and off peak. If you have different types of peaks other than those two, you want to make sure you get those in there. You want to make sure you get that in there if you can. Being an engineer and being more concerned about the energy aspect than the cost, it wasn't always as critical to me. But Energy Star Portfolio Manager, from my experience over the past 30, 35 years that I've seen it out there, has done more to save energy and drive energy down than I can do with a lot of different other things. So it's been a very useful tool, an important tool. All right, with that, any other thoughts or comments? Other than those who have Energy Star, you may want to figure out how you can pull the data out of there. There's ways to export it. Get that data out so you have it stored someplace so you don't lose it.
And periodically backing up that data is a good idea, no matter what kind of service you use.
Yeah.
You can download your entire portfolio as a CSV.
Okay.
That's
Yeah,
the most rudimentary way to do it. I do it every time I start messing with things.
Good habit to be in.
They also have the API you can tie in. They won't let you do it unless you sign up for their testing environment, though. I'm not quite there yet. Close though.
There are
You're not
also
worried about it.
third-party tools that will allow you to do it as well, though you have to pay for most of those.
Another couple things about energy tracking. Robert mentioned there's a lot of different services out there that you can utilize. At my school, I think I've mentioned we use WegoWise. But there's a lot of online services just like that out there. And they all have their pluses and minuses. But the biggest problem I see with going to those type of services is they establish a connection with the utility for your metering information, and they go and they pull it once a month. But that's kind of a dumb poll where they don't really have good enough eyes on it to determine if there's errors in the data. I mean, they have some methods, but generally things get past it. In addition, when they grab that data just once a month, it doesn't necessarily get the information of adjustments that are made between meter readings or between bills. And that can fall to the wayside. So it's something where if you have a service like that, you really do need to keep your eyes on it, to watch it, to make sure that these errors aren't coming through to your data. And I don't, the majority of services out there don't really do a good job. Oh, it's WeGo-wise, by the way. Yeah, the majority of them out there don't do a good job of filtering the bad data out of there. I'll type it into the chat what the name of it is. I'm not promoting them in any way, shape, or form. I've just seen it, you know, it's a service that if you get used to it, it's good, just like all the other ones out there. And there's it suffers from what all those services suffer from, and that's that lack of good scrutiny on the data going in. And that's where a lot of these services fall down. And maybe I'm a little bit prejudiced on that because I've been providing energy tracking services for customers for the past, almost 40 years now. And we have 3 sets of eyes that hit that data before it goes out the door. So it's not just some algorithm doing it, it's actual people making sure that what we see is good. So it requires somebody doing that, I think. So that's something you have to do. Energy Cap, another program that's been out there for quite a while. All right. So I guess with that, Robert, we're going to go to our survey.
Fantastic. So I am putting a link to our survey in the chat. I will repost it here in a few minutes. It won't take you much time. It's a total of 25 questions. And I think, 15 of them, 16 of them are multiple choice. Just click the checkbox and move on type ones. If you want to make extra comments, you can. And one of those ones that's not a checkbox item is your name. So I hope that one doesn't take too long either. So if you could take just a handful of minutes to go ahead and fill out this survey for us, please. This is information that we gather both for our own edification and improvement on how we've done, and also so that we can use it as evidence to continue getting funds to be able to do trainings like this for free. So that's really a very important thing for us. If you've gotten anything at all out of this training, please do us the favor of filling out the survey to let us know so that we can use that as evidence to keep going. If you haven't gotten a single thing out of this training, please also fill out the survey and tell us that, because we really need to know those kind of things as well, again, for our improvement. But other than that, we're going to take a break. I'll repaste the link into the survey again here in a minute if it slides down. Ted, anything on the survey?
No, just be as truthful as possible, because that helps us improve for the next round. And that's really
Absolutely.
important.
Absolutely.
And, be critical, because that's where we get the most improvement from.
All right. So we will be back at 5 minutes past the hour to continue on, and we will be getting into our actual energy analysis next. So fasten your seatbelts and stay tuned.
All right. All right, so back from the break. This is where we're all gonna do some hands-on. Has everybody downloaded their data? From this morning?
And we know we're going to be doing a fair amount of stuff with this data. So if you get lost at some point, don't worry, just take a little bit of time to catch up. Remember, this session is being recorded and you can view it afterwards using the same link that you used to get in. So if you get lost or need to review this data again later, just come watch the recording.
And Robert, time-wise, how much do we have for this? I think we got about an hour, right?
Yes, sir, that is correct.
Okay.
Yeah, maybe a little bit more actually.
A little bit more?
Yeah, we're a little bit ahead of schedule.
Well, good. That's real good, actually. So in this part, we're going to be doing using the CSV file you downloaded. We're going to open it up in Google Sheets and have everybody work with their data. And we're going to do a little bit of switch here in just a couple slides, but get in that data. Is there anybody who cannot use Google Sheets? Oh, and yeah, if you haven't downloaded that trend, get it downloaded. All right, it looks like everybody's able to use Google Sheets because we're going to be working with it. Those who are really fluent with this, you'll probably pick up some things because I've been using some form of spreadsheets for the past 10, 20, 30, 40 years. And I'm still learning more on it. So, and this was just with Google Sheets overnight. I was working some things I didn't know about it. So you always can learn more with it. Those that are not familiar with it, this will be good to help you get your feet in there and start to understand a little bit better. As Robert said, just do your best to keep up with us. Don't be worried if you get behind. Just do your best to pick up what you can from it. We're going to be going through equations. We're going to be working manipulating your spreadsheets. On those spreadsheets, we're going to be doing some simple graphing. Graphing can get really complicated on these. Manipulation of your spreadsheet can get really complicated, but we're just keep everything really as simple as possible. And we're going to introduce you to some formatting on these spreadsheets. But the end result is we're getting to this being able to calculate the energy consumed by your trends before and after you made a change. And Robert, can you describe those before and after changes?
Yeah, the major event that we're using as our before or our transition point is when we started editing the schedules so that we can see the point where we started to make changes with the systems. And over time, any additional changes we made would then be cumulative. So I think we did schedules on the second week, if I remember correctly. So going back in the data about 3 weeks, that should be somewhere around your transition point.
Okay, good. So keep that time frame in mind because we're going to be using that. So first of all, I think I don't know if these slides aren't going to do me any good, are they, Robert? Because I'm going to have the slides up and other things up. So I'm going to stop my share. And I'm going to stop my slideshow. And bring up my spreadsheet. If I can find it, which I'm sure everybody realizes the challenge these days. I've got 3 different monitors, and where is what I need? So I'm gonna bring that up here. And I'm going to go to a different method for my slides. Actually, I have both of them up here, so this is good. Sorry if I was talking to be in the background. It's just one of those things that need to happen while I get it set up here. Back to share. And this time I'm going to share my whole monitor. And what I'm going to do is I want to just test this. And do you see a different thing creeping into the side there?
So
Robert?
far, we just see your out of presentation mode Chrome window.
Okay, so I did not get that right. Let me stop my share. Reshare. Do you see I'm gonna bring, can you see the everything creeping in on the side? Another set of slides?
Nope, still just the slideshow.
Well,
We can
won't
see
worry.
that you've got another tab available there, but
yeah,
nothing overlaying it.
all right, it's not doing what I thought it would do, but this is okay. So when you go to your data, this is what you're going to see. Something very similar to this. Is that what everybody's seeing? Put this over here. Robert, I'm gonna ask you to watch that chat, just make sure we're catching things.
Yep,
As
I'm on it. We've got a couple of affirmatives so far. Yes, we are
Okay.
seeing what or similar things to what you are.
So we're just going to kind of take a look at our data that we have right now. And the best place to start with that is to just kind of glance at it quickly. You'll see here that we have in this information, we have the timestamp, I call this. It's the date and the time that the data was collected. And so yours may be crunched and give you all hashtags, but if you want to just go ahead and you can grab up on the top of the column, you grab the bar in between the different columns and you can expand it or contract it as much as you want. Or if you double click on it, it'll automatically adjust to the maximum width of the item in that column. So now if you look at total power, it's quite longer than the width of that column. If I double click between the two columns here, it'll expand it out to the full width of that column. So you can go ahead and do it if you want. But the main thing is you want to be able to see these numbers here. Then we want to just say, we look here, we got row 4. So we have columns and rows. Row 4 is where our data starts. And you'll see that mine's a little bit old already. It's just from the last day or so here. So doesn't have as much data as yours has. So if I go down and I'm just going to hit my page down. So go ahead, hit your page down. Just keep going. And going until we get to the end of data. Now there is a simpler way to get to the end. I'll tell you that in just a bit, but mine goes down to 1,369. What does everybody else's go down to? You probably have more rows in yours. Anybody?
Go ahead and throw your answer in the chat, folks. Gene's got
1509. Okay.
1509.
So it sounds like because of that, most people have somewhere around 1,500 to 1,600 rows. Now, if I want to get from my top to my bottom a lot quicker, I'm going to press my control key, hit home. If I go control home, it takes me up to cell A1. If I go control end, it takes me down to lower right, and that takes me down to row 1371, column F. So you can get around by hitting control N, control home. Now, if you have a lot of columns, that's not the best way to have to do it. It kind of can get you lost a little bit, but that's okay. Because if, let's say you have columns out to AA. Well, if you're on row 1371 and column AA, you're not going to see this first set of columns. All you need to do is you just press your home key, and that takes you to that first column. You see that? So that's another way to get around a little bit. So we're going to go back home. And I want everybody to arrow down to your date there, which should be A3, cell A3. When you name your cell, it's column first and then row. I'm going to hold the shift key down. Hit control end. And it's thinking. And it didn't do it. Okay, so different spreadsheets do different things. And so this one didn't do what I thought it would do. Some of my stuff is a hangover from Excel. So Excel is more powerful than Google Sheets and gives you a lot better functionality. But because of that, it has a little bit more complex method of doing things. It gets a little more complicated. So I'm just going to go and I arrow. So I'm on my date and I arrow over to column B. And then I'm going to have to page all the way down to the end of my data. So go ahead and do this with me. Go all the way down to the end of your data. I've got mine highlighted that way. And when you're done with that, what we're going to do is go up to the insert menu item up here. Insert. So I still have this all highlighted. I'm going to hit insert. And then go down to this thing called chart. So go ahead, click insert and then chart and see what happens. I'm going to press mine right now. And this is what I get. I like to see this in a full tab view. So you see these three dots here. I'm going to click on them. And I'm going to go to move to its own sheet. So what we're seeing on here for my set of data, does anybody else have something look like this where it's not complete or it looks really goofy like this? Ah, Gene says no. That's good. This process is part of filtering out your data. You got to get rid of the stuff that makes no sense, which I have things in mind, my set of data that don't make sense.
And this is part of that data review process that we talked about right after we downloaded these trend logs. So
Yeah.
this is part of that. Again, taking a look at the data and just, does it make sense? If it doesn't, how? And what do we need to remove or add so that it does make sense?
Yeah. Is anybody come up with some other stuff on their graph that doesn't make sense? So if you do, let us know right now. And Robert, I think I'm going to just run with what we got. I know we talked about sharing that other file, but it seems like everybody's up on here already. We'll just stick with this.
Sounds great, man.
All right. So this is a simple graph. And it's helping us to start analyze the data. First being that we have a problem with our set, or with my set at least. So I'm going to go in here, go back here, and figure out where my problem is. So if I go to the chart again, you can see that there's some data here from the 1st of January. Well, we're only supposed to be having 2-3 weeks of data, Robert said. So there's some bad dates in here is the problem with my data. So I'm going to go back in and find my wrong data. And it happens to be right down here. I can see I got some 2024 data. And that's where it is. So here's May 7th. And then all the way up here, I've got May 22nd. So it's these points right here that are bad for me on my set of data. So if I just take and I highlight these, and what I'm going to do is this. I'm going to click on the first row that's bad and just arrow down and highlight all these rows. And then I'm going to go up to edit, delete rows. So now I have those rows deleted. I'm going to go back now, take a look at my chart and see if that got rid of the problem. And it seems to have not done it. What I think I need to do is probably refresh this screen. Or I may need to regenerate the chart. Yeah, I'm going to need to regenerate the chart. So I'm going to delete this one. Actually, yeah, I'm going to delete the chart. First, I'm going to go and edit it. It should tell me what the series are based on. The range, and it's not. Okay, yes, it is. Right here, see trend data, A3 through B1361. Well, if I go back down to the bottom, you see, I didn't get rid of the last bit of bad data. So you're always going to make mistakes like this, where you miss something and you got to go back and adjust it. So I'm gonna delete these two, or this one. Now it should clear up. And there we go. Now we have a more typical pattern. Everything's going up and down, up and down. And this is extending from May 9th. And that might be as far back as May 7th or 8th back here. All the way through, in my case, May 21st. So that's looking okay. Now, we have the data that makes sense to us. And you always want to be doing it. Now, we look at this data. We have a spike back here. And if I go to that spike, I can see what that spike is. It happens to be on May 8th at 4:45 p.m. And it gives me the total. So I can do that with any point on here, as long as I can get into that level of detail, because it gets kind of tight together. It gets hard to get your mouse on the right one. But I can get in that level of detail and see what's there. So now, that's our good starting point. So that kind of gets us into our next step here. And we want to look at this. I'm going to go back home.
Can I interject for 2 seconds, Ted?
Yes, please.
When you are modifying your data, normally I would make this a discussion item, but for time, well, I'll just put it out there. Anytime you find errors in your data like this, removing them is perfectly okay in most situations. But when you do find those types of errors, it's also important to figure out why that error occurred. In this case, we know that this error occurred because when we logged in and first started working on these units, the time wasn't set correctly and the date wasn't set correctly. So when the people logged in on this one, made that time and date change, it put that big jump in our logging in. That's the source for this piece of data error. And you may very well see a very similar error in your own data that you're seeing, because I think almost everybody had to make that same change. But that why you have a problem with your data, maybe it's, again, a meter got changed, so your readings are off. Whatever that reason, you do need to spend some effort in discovering what it is.
The other thing that I forgot to mention was I like to always save my original data some way, some shape or form. So if you go down to the bottom where your tab says trend data, you right click on it. And in Google Sheets, you can duplicate it. In Excel, it's move or copy, but here it's duplicate. So I'm gonna go ahead and duplicate this so that I have an original set in trend data, and then I'm going to manipulate my copy out. So I have that available to me. The other thing that's really interesting, and this is kind of the same way utilities provide data, is the date that's at the very top is the most recent data that was collected. In this case, on my screen, it's May 22nd at midnight. So the bottom has the oldest set of data. I go down there. That's May 7th at noon. Generally, when you're thinking about this and you're working with data, you have the oldest data at the top and the newest data at the bottom. It's best if we sort all this so that we get that accomplished. So that's going to be using our sort function. And the way to do that is to go back and highlight this. So if we go in cell, for me, cell A4, you want to go to your first date up here on top, or which would be your oldest or newest, I mean, and arrow over to the column B, which is your power. And we want to go all the way down to the bottom of the data. And we're going to sort this when we get all this highlighted. So that instead of from newest to oldest, it goes from oldest to new. This will make life a little bit easier as you analyze things. So I'm going to go, I got it all highlighted. And I can see it's highlighted from, say, cell A4 to B1361. You can see that in the upper left corner here. And I'm going to go data, sort, and I want to go from oldest to newest, so that's going to be Z to A. Did I do it? Nope. Sort, I got to go from A to Z. There, now it flipped it. So that the newest set of data is at the very bottom. I hit Control Home, get me home. And the oldest set of data is at the top. So that's another step we want to take. Now, I'm just going to talk quickly about, can you see that, Robert? No. Huh? Okay.
Nope.
Here we go. I want to talk a little bit about equations that we use. And for energy, with our trended data, the units on it, and Robert, correct me if I'm wrong, the units are watts. Not
You're
watt
correct.
hours, not kW, not kilowatt hours. It's watts. So this is an instantaneous grab of data. It's telling us how much power we're drawing at that moment. We want to take our reading, which is in watts, and convert it to kW because our billing structure is based on kW and kWh. So we have to take our watts and divide it by 1,000. We're not going to do that right now. We'll do that in a bit. But just so you know, that's one of the equations we're going to have to go to. The other one is we're taking 4 readings an hour. We're basing energy on kilowatt hours, which is the kW average for an hour. So we need to add up all the readings we have for 1 hour and then divide it by 4 because we have 4 readings an hour. The third item is we need to be able to convert these into, when we look at energy intensity later on, into BTUs. And so a kilowatt hour has 3,412 BTUs in it. A therm, by definition, is 100,000 BTUs. Anybody know roughly how to think of a kilowatt hour energy? There's a real simple way of thinking of it. I'm sorry, not kilowatt hour, BTU. I'm sorry, BTU of energy.
Isn't it the amount of energy that it takes to raise 1 gallon of water 1 degree Fahrenheit?
1 pound of water, 1
1
degree
pound.
Fahrenheit. Yeah. Yeah, so a pound of water is 16 ounces. So you think about your generic 16-ounce bottle of water. 1 BTU will raise that 1 degree Fahrenheit. that's roughly the equivalent of taking a farmer's match or a wood match and lighting that, and the energy that comes off that match is roughly 1 BTU. So if you could harness all that energy coming off that match when you light it and put it directly into the water, no losses, it would raise it 1 degree. All right, so that's some background. Now, next thing we're going to do is we're going to start to manipulate this spreadsheet a little bit. And we're going to do it by inserting columns. We're not going to do any row insertion at this point, but we're going to insert some columns and get our spreadsheet set up for us to work with it to do some calculations. And this is going to be stepping through insertion, and it's going to be getting us set up to work with cells, referencing cells, and then formatting those cells. So I'm going to go back to this spreadsheet itself. And the first thing I want to do, I got to go to my other set of slides here so I can see what I need to cover. I want you to start with F here, column F. And this is a big difference between Google Sheets and Excel. Excel automatically gives you this huge playground of cells to work with. It goes out to, I don't know how many columns to the right, and it goes to, and I forget how many cells down it goes, or rows down it goes, but it's enormous. Google Sheets really restricts that at first. You can add more, which is what we're going to do here, but it keeps it smaller for you, more manageable to begin out with, which is nice, especially for those that are just starting out with this. So I'm going to take, I've got 1, 2, 3, 4, 5 columns highlighted now. Everybody go ahead and highlight those 5 columns. And then I'm going to right click on the column headings here, the numbers or letters. And I'm going to go down to insert 5 columns to the right. So now I have this extra space over here. I'm going to do the same thing to the beginning of the columns. I'm going to highlight 1, 2, 3, 4, 5 columns. Right click on here and insert 5 columns to the left. So now we have room to work with on both sides of the data. And that's helpful for us to be able to manipulate things and make notes. Because one of the things that we talked about earlier was you want to document what you're doing. And doing it right in the spreadsheet is a good way to do that. So let's just go ahead and talk about some of this documenting. I don't know, Robert, can you again describe what we did? We in week 2 adjusted schedules to impact energy, correct?
That's correct.
What type of thing did we do with the schedules, do you know?
We optimized the schedules to match our occupancy actual occupancy. Previously, they were set up as 24/7, and we adjusted them to match the occupied times for our specific zones.
Okay. So there we put a note in there. And what's a good way to describe the system that this is?
So
what's the power for?
This power would be for the entirety of our floor. So it is our air handler is our primary load, but it also takes into account the energy being used to supply hot water and chilled water with our floor specifically.
All right, so lighting, air handling unit, and hot water, chilled water supply.
Correct.
Okay. We would typically like to put the dates, but the dates are actually posted for us up here. This is not the right one. We want to get the correct one here. And this is where I'm going to show you a cell reference. All I need to do is just press equal on my keyboard. So I got an equal sign. And then I use my mouse. And this is the first set of data. So I click on that and it hit enter. And now it automatically puts it in there. I'm going to go up on top. I'm going to double click here. So it expands the column out to fit the data. So now I know this is my start. And this is my end. So I have that data there. So it's just a matter of starting a document so that when somebody else looks at this, they have a better understanding what you did. And just as important, a day, a week, a month, a year from now, when you go back and you look at this, you can recall what you did. It's a really good method to make sure that this just doesn't turn into garbage in the future for you. Then I'm going to do some more cell referencing. I want to go over to the top row here of data. And I'm going to reference the date to be column A4. So I'm just going to say equals cell F4. I'm going to do the same thing with column B. I'm going to make it reference the same date. And I'll explain why in a little bit. So just go ahead and do this as I'm doing it. The last one, C, I'm going to reference the power. So now you're going to notice that in cell C4, it's a really goofy number for power. It's giving me a date and time instead. So we have to format these things. Well, first of all, what I want to do is I want a day of week here. I want the time here. And I want the watts power here. That's redundant statement. Watts is power. Power is watts. So I'm going to take the power off, but I want to just drive that home. So day of week, that doesn't tell me day of week. Well, it does, but I want it to be more logical. So I'm going to go up to format and go into the number. Go over here. I'm going to go into custom date and time. When I do that, I can select all these different types of ways to view the date. I just want the day of the week, which is Tuesday. And then you see it changes it up here. If I apply that, it changes it here. So again, the way I did that, I went to format, number, down to custom date and time, which I guess I could have went here and would have did it there too, but custom date and time, Tuesday, and I applied that. I want to do the same thing, but on time for this cell. So I'm going to go format, number, and there is a slot here for time. And I'm just going to click on time. Now I want to do this because I don't know about you, but when I see this number here, I have to look at it and think about what I'm looking at. So I just want to be able to quickly assess what it is. Wednesday and the time. You could do the same thing for, say, the month and day of the month. We're not going to do that here, but that could be some other useful information for you. Now, watts is also a date, so we need to go and format that. Anybody have any questions on doing that before I move on? If you do, just speak right up. I'm going to just kind of keep on plodding through this. So for watts, I want to go to format, number, and I just want a plain number. So I'm going to click on number here. And it gives me watts carried to 2 decimal points. I'll throw this out to everybody. What do you think of having 2 decimal points there? Or 2 digits past the decimal point? Is that useful information or not? And we want to think about this in terms of the units. It's wattage. A watt is a very small unit of energy. But yet we're measuring close to 100 watts on a regular, 100 watts to thousands of watts on a regular basis for this. Anybody have a feel for, yeah, Damien says it's not useful. What do you think would be a useful number of digits, if any at all, for that matter, past the decimal point? Anybody have an idea? Yeah, I would agree with Damien, none. So we can change this readout by just going up here where they have this arrows to the left to make it smaller, arrows to the right to make it bigger number of decimals or more decimals. So I'm going to click this twice, and that changes it to 97. So that's will help with you understanding your data a little bit better. And I see Adam talked about Energy Star only takes up to 2 decimal places. And that's because for what Energy Star does, the thing that you need 2 decimal places for is the dollars. But otherwise, you know, everything else is meaningless for Energy Star to have decimal places. So that's why it only lets you have 2. That's why I'm guessing why. I'm haven't talked to the makers of it, so I don't know for sure, but that's why I'm guessing.
Excuse me, Ted.
Yeah.
Hey, Gene. Hey, look, that last column C, could you give me just the quick basis? So you're clicking that, right-clicking it, you get the number there. I'm there, but how do you how's your conversion again with the chart? I mean, well, with how you got it to the single whole number? Oh,
So
format.
I went up to format, first of
Okay.
all, and changed it to a number here.
Okay.
And there's 2 steps to this. So we changed the number. You see this number is giving me 2 decimal places.
Correct.
So that changes it to 2 decimal places here. Then if I go up to this menu bar here, I have the choice to decrease the number of decimal places or increase the number of decimal places. So if I press increase, it just gives me more and more.
Yes.
If I press decrease, it gets rid of them.
Less. Yes. Excellent. I got it. Thank you.
The thing to remember about this is that it doesn't lose those decimal places. So it's still actually in that cell. It's just that it doesn't show them to you, doesn't present it to you. So if I go here and I reference this cell again, it's going to give me all the decimal places. If I were to go back to format, number, it still gives me the decimal places. So it's still in there. So if you sum up a column of these, it will add up the whole number and the decimal places. So it may not equal what you think it does. So you got to be aware of that. But for what we're doing, that level of accuracy doesn't matter right now. So I'm not going to pull out a rounding function or anything like that. So this is just visually taking it off of there. And Robert, I think it truncates. So we have now 3 new columns that really are the same as what we imported or exported. It's just that we're formatting it differently. And I'm going to highlight those 3 columns, that row, and start arrowing down with the highlight. And if I didn't say it, the way you do this, you hold your shift key down, you arrow over, and then you keep your shift key held down, you keep paging down until you get down to the end of the data. Control D. So Control D copies it all the way down. I'm not sure I said that before, but that's what you do. You just press Control D and it'll copy that data all the way down. Everybody seen how to do that? If not, let me know. So I went back home and now here's all my data in there. And for me, what this does, and everybody's different in how you do these things, so you may want to do it differently. But for me, it gives me the day of the week and the time, which is important because I want to see over this past 2-3 week period the information so I can decide what data I'm grabbing, what data I'm not grabbing. So we have that, and we're going to do just a quick, now I'll grab a data before and after. So Robert, I'm gonna need your assistance here, and maybe people out there too. How shall we define the before data? What days and times? Start and finish.
So I can give you my take, but I'd like to hear anybody else what your thoughts are first.
That's my coffee cup scraping the desktop, by the way.
So great point question. Carlos, the question is, when do we define what our before period is before we started making changes? And how do we define our after period? When or where in the document is that transition? And I think for us, in this case, since we know the date that we started making our changes was April, where do we go? Sorry, May 9th, not April 9th, May 9th. We can use that as our transition time, right? We can use anything up to about 8 a.m. on May 9th as before, and anything after about 5 p.m. I'm sorry, 3 p.m. on May 9th as our after. kind of there in the middle periods where we're making those changes. So that would be the easy way in this. Not always going to work that way, though. Unless you're doing really good documentation and note taking when you're making these project or implementing these projects.
So that would also be the end time for the before case. 3 p.m.
I'd argue that it's before that, but that's fine.
Well, yeah, and exactly. You typically have like a buffer between starts and stops.
Yeah.
So let's put a buffer in there. We'll make it, let's say 8 a.m. just to make it a little bit different. And you see, I'm kind of putting notes in here as we go along, which would be something that you'd probably want to try to do as you're getting this work done. That way we have it documented for ourselves. So where should we put the start date for before? Any ideas on that? Keeping in mind that when you try to do energy analyses, you want to try to be able to compare similar things, similar time frames. Now, we're not going to go into all that much detail with our example here, but weekdays are typically different than weekends. And so you probably want to think about that. And Carlos mentioned that we should probably use the same number of days we have on the after period. So that's a good way to do it also. So we have from May 9th. I'm not seeing a calendar in front of me here. Where's the calendar?
What are you looking for, Ted?
So May 9th,
So Friday.
Friday. So we had a full 2 weeks of data after we modified the schedules.
That's correct.
Really? Wow. I thought you did that last week for some reason. All right. So that is going to be a full 14 days. So we probably want to try for about 14 days. So that's going to put us back to April sometime. April 25th.
April 25th.
Yeah. And the way I was able to come to that real quick is if you go up here, I can see what my cell's telling me. I just said equals to May 9th minus 14 days. And that's what gave me April 25th. And we want to ideally get about the same amount of hours in there. So it's kind of a rough thing to deal with here. We don't have the exact one. We'll just see what we can get. So, I don't know, because if we go to 3 p.m. here, today we don't have data going to 3 p.m. So it's just gonna not quite be right, but close enough for us for what we gotta do today. So now I know what the before case is and what the after case is. So I'm gonna start with the after case. And for me visually, I'm gonna want to go and highlight things. Now, my data is different than yours. So you're gonna get some different results because I don't have going through today. I only have going through Wednesday. But I'm gonna take and highlight from my last bit of data down to May 9th at 3 p.m. So here's May 9th. That's 3 a.m. Is that right? Yeah. Robert, help me here. I think I'm not looking at this correctly.
Sorry, I was typing in the chat. What's up?
I want to go down to May 9th at 3 p.m. It looks like I got that right here,
Yes, you do.
but I'm noticing some irregularities in my data.
Yeah, that is interesting how it's changed over. It did skip a period for sure.
And that may have just been when when you were doing some things on the system. I don't know, but I'm not going to worry about that right now.
Yep.
But these are things you want to note.
Yep.
So for now, visually, I just want to be able to see what this is. Okay. So I'm going to highlight. Now I know that's might be my after case. From April 20, I'm sorry, from today, which is up here, which for me is that date, through May 9th at 3 p.m. So I got that highlighted. Now the before case should be from April 25th at 3 p.m. to May 9th at 8 a.m. So I'm going to scroll down. Here's May. May 9th. Something's not quite right here. Did I sort this data? Yeah, I did.
Yeah, you did.
Did I put the wrong overlap of data here?
Mhm. No, you're right.
Well, let's just start this off and see what we get to here. April 25th at 3 p.m. to May 9th. I don't think I had data going back that far. So I'm just going to have to go back here to Thursday. No, my data is not sorted.
Yeah, it is.
Quite
You don't
right.
have data that goes back any further.
Yeah,
There
I
is
flipped
some
it wrong.
oddities with that. for
I
sure.
flipped this wrong. That's what the problem is. So I was doing the before case or after. So the after case should be all the last data we have going back to May 9th. That was my issue. I got flipped around with what we're working on here. So I'm gonna go back up. And go to May 9th. And I want to go to May 9th at 3 p.m. I think. So I'm gonna go and highlight this. I'm going to go to a different color. I'm gonna go to green. The before case really should be, I'm gonna reset that. Really should be as far back as I can go, which is May 7th only on my data. That's what was mixing me up. May 7th on my data to May 9th at 8 a.m. So I'm gonna scroll down here to May 9th. And we don't have it 8 a.m. just due to something happened with the data here. And I'm gonna make this that highlighted color. So now I have two distinct pieces of data. And I can start to analyze the before case, which is this. And then the after, which is this. So is everybody able to follow along with this and see where we are with it? When you're working with big spreadsheets, it's a very methodical process you have to follow, and you always got to ask yourself questions about whether it's making sense or not, which you've been hearing me do all along here, trying to make sure when I'm not seeing something that's not quite right, second guessing myself, checking back to make sure we're in line. So now our before case, I had put in green. So I'm going to do that here. It's in green. And the question is about if you don't have the same time frame before and after, number of days or number of hours, should you be working with averages? And a short answer to that, but not necessarily accurate, is yes. Probably the correct answer is it depends upon what you're looking at and how you need to manipulate things. And the reason I say that is if those number of days that you take, let's say that, for instance, we want to look at a 2-week period. But my before data only has 9 days. Well, then I take all the 9 days I have, but guess what? That set of 9 days only has 2 weekend days in it. Whereas if I had 14 days, I would have 4 weekend days. Whereas my after case has 14 days. And well, in my case, I don't, but let's say yours does. Then you would have 4 weekend days in there, 2 full weekends. So now you're comparing apples to oranges because you're weighing things heavier with the 4 days of weekend in there than you were with the first set of data. So it gets tricky when you're looking at these energy analysis. You have a lot more things to think about with your information. Even with, you notice I struggled a little bit with the time of day for the start and stops not being the same. Well, we're missing from 8 a.m. to 3 p.m. on a Friday of data. And one has that, the other may not. Well, on a Friday, that 8 hours of data could be very important. 7 hours of data could be very important. So, and realistically, the more important your results are, the more careful you should be about making those time frames and data match up. We don't necessarily have to be accurate with what we're doing today. So it's not overly critical. So we're going to end up taking that average number.
And one thing to keep in mind with what we're working with today is far from a ideal example of the data, because our simulation is running for such a short period of time, both before and after the changes were made. We may not get the greatest results out of it, the most accurate. You typically want more data on both sides and you want as many of your conditions, your variables, to be the same as possible. So a lot of times we'll try and use weather normalized data to find similar months in like a previous year before the changes were made to use as comparison or as a baseline year.
And that type of discussion gets us into this whole area of measurement and verification. There's international protocols to follow for that process. It gets into a lot of detail. Obviously, we're not going to get into that here today, let alone will you probably ever need to get into that, because that's usually when there's a lot of money on the line. You want to make sure you follow those type of protocols. And I've done some of those projects. And I've had a lot of money on the line for that. And that's kind of a scary thing to do. When I have dang near $250,000 out there, it gets kind of rough. This process we're following right now, trying to drill down, we actually probably have enough data here to do a more accurate job. It would entail us going in and splitting things up day by day and getting consumption on Mondays before and after, Tuesdays before and after, Wednesdays before and after, each day of the week before and after, and doing averages for those, or taking weekdays versus weekends and getting averages for a couple of those and doing some analyses that way. So it's just a matter of when you have the information, like in this case where it's not ideal to give you a broader range, you have to drill down more into it and then slice and parse it the way you need to make it as accurate as possible to be able to expand it back out to what we're going to be doing to a full year of data. It's just, it'll be less accurate overall with less data you have. That's just the nature of the beast. All right. So the next step we have is, I just want to take quickly, actually, we already looked at our graphs, so I'm not going to look at before and after graphs. If we have time, we'll go to that. We're going to do some analyses. Now, what I want to do is summarize the data before and after. And this gets into that averaging and things like that. So we have our before and after times. What I want to do is to take and calculate the number of days. Turn that into hours. So we have days and hours for each of them. Then I want to take in some total power. And I'll explain these terms in a little bit. And I think we'll start right here. So the number of days. So now we're going to get into using equations and cells a little bit more. And to figure out how many days we have in a period, we're going to just take the beginning and end dates, take the difference between them, and that'll give us the number of days. And the way we do that is we just say equals. We're going to start with the before case. So I got to scroll down. And this is why I highlighted things to make it a little bit easier to scroll down. I'm going to scroll down to the first date here, which, let me see here. Actually, I want to go to the last date of our information here. Am I doing this right? Am I doing the before or am I doing the after here? I'm doing after. So I'm gonna take the. What's going, a lot of numbers down here. So the very end of our data, I'm gonna take that time, that date, subtract off, so I hit the minus key. So I got equals the last cell, the Thursday, down here. And I'm gonna subtract. And I think I may have to move my cell a little bit later on, but we'll get there. So you see it's kind of tedious. I'm gonna subtract that off. So this is the after case, because it's the green one. That's the number of days. So to get the hours, I just take the number of days and multiply it by 24. So it's 297 hours in my before case. Or after case, I mean, I'm sorry. I think what I'm going to do. I have these highlighted wrong color-wise. That's what was mixing me up. I'll take this coloring off of here. My before is actually the yellow. My after is the green. I'm doing pretty good on the color blindness today, aren't I? Getting this right. And then we go in and summarize all the power. So to add everything up in an area, you go equals SUM, oops, SUM. And now we just need to select our values. So I want to sum up all my after case, which is my green. Now I can sum them here. Or I can sum them here. I'm going to sum them up here. And it doesn't matter if I start to begin here, end of the set of data, because it'll add everything up. And then I'm just going to scroll down to the end of the data. And remember, this is adding all those things past the decimal point off. Now you can see it's giving me from cell 173 to C11361. And it's telling me what that all adds up to here. And if I hit enter, it takes me right back up here. And I have my value. So this is in what? What units? It's going to be in watts. However, our billing is not in watts. Our billing is in kW. So to change watts to kW, I have to divide by 1,000. So I'm going to go equals divided by 1,000. And that's what it gives me. Now I have a lot of decimal places here. So I want to get rid of some of those. So I'm going to go back up. I highlight my cell. I'm going to go up to the reduced number of decimals. as a general rule, if you're dealing with more than a KW or two, you don't want to have decimal places after it. So we have 10,000, so I'm just going to take them all off. So that's summing up that whole column. Now, is that going to be kilowatt hours? Anybody know the answer to that? Well, it's going to be equal to KW divided by 4, KW total. Because we have 4 readings an hour, and it didn't like that. So I had to put a,
You've combined your note and your equation into one cell.
yeah. Right here is equals, but I'm gonna go equals here, divide that by 4. So I'm referencing my total KW, dividing that by 4 to get KWH over that same time frame. Is this making sense, Robert? Am I going too fast or missing some parts?
No, it's making sense. Dan contributed a moment ago, but it was in a direct message, so you probably didn't see it. But yeah, he agreed that no, it wasn't going to be kilowatt hours, just kilowatts.
Okay. So there's our kilowatt hours. So that's our after case. Now I'm gonna take and move this over a little bit. So before, we gotta do the same thing where we will take all the, in this case, the yellow areas for dates. So we got equals the end date and time, which will be right here, minus the first date in time. So it's telling me I only have 2 days. Somehow that's not making sense to me.
No, that's about right, Ted, with the
5-7 down
times we
to
chose.
5-9. Yep. So, back to the point in the comments, I think it was Carlos said, we're not comparing anywhere near the same number of days in these 2 sets. So it's going to be very different. Now, again, I prefer not to have all these decimal places, so I'm highlighting both of them and just going to 2 decimal places in this case. And then to get the number of hours, I'm just going to multiply by 2. And actually, I'm just going to, if I highlight this and I arrow over one to the blank one, and I go Control R, Control Right, it'll copy that over there along with the formatting, so I don't have to go and reformat that. So that was highlight both cells and go Control R to get over to the right. There's a lot of shortcuts and things that I will go through that are difficult to follow along with, and I apologize for that. Somebody could just stop me and ask me if as we go along, make sure I get those to you. Then for our power, again, we see we have this equation summing up all the power in column C for those times and dates. And so we're going to do the same thing here. Equal sum of the power from C4. And it doesn't matter which order I take these in because it just is adding all them up anyway. For the whole before case. I hit enter. And there we have the power for that. I'm going to expand this out. I'm not going to double click because if I double click on this, oh, I guess it did. In some cases, when you double click, it expands it way out like it did just there. That's because up above here, I have a cell that has something that's that long. So I don't want that. So I'm going to just bring that back in. So you can see we have two very different time frames, resulting in two very different total power. I'm going to go ahead and this cell here is just a matter of divided by 1,000. So I'll go over there, control right. I get my 1,000 there. And for the kWh, it's just a matter divided by 4 periods in an hour. So now we get to the averaging part. If we are trying to compare similar time frames, and I realize we're making an assumption that every day is basically the same pattern-wise, which is not true, but in this case, we're just going to make that assumption. We want to get an average kW over that time period. So average kW is going to be a matter of taking our kilowatt hours, let's say equals kilowatt hours, and dividing that by the number of hours that we accrue those kilowatt hours over. This is an average kW. You'll notice that it's going to be a much different number than any of the numbers that you see in the watts column. So it expanded out to all those decimal places. We don't need that. So I'm going to just bring it down to here, which is basically 9 kilowatt hours average there. And if I just take and highlight to the right one cell, I go Control R, that copies it over. Or I could just went and edit, copy, edit, paste, and then that gives me the same result. So now in this case, I look at it and I have average kW after of 9, average kW before of 10. What that results to us is that we want to look at this. What type of time period do you want to look at this over, Robert? A week, a year, a month?
Well, if we maintain our schedules as accurately as they currently are, but let's assume a school year. So let's call it 9 months or 10 months.
10 months. Okay, so if we go equals 10 months divided by 12 months out of the year times 8,760 hours in a year, that'll tell us how many hours in a school year. Now, that's not quite, in thinking about it, accurate, is it? What would everybody out there think would be a better way to calculate the hours in the school year? Any ideas? Weeks? Okay. What I'm thinking about is that, you know, that's if we use 10 months, let's say like we did, it's including spring break, Thanksgiving, between semester break. Do we really want those in this number? So I'm bringing this up because you need to think about when you do these things, what's accurate for what you're trying to get to. Now, for what we're working with, we're just trying to come up with an example, a way to step through and calculate energy. Our best guess right now is 7,300 hours. If we use, like in Gene's case, weeks, well, the weeks would be closer to 180 days is in a school year. And we're only counting during the week, so we divide 180 days by 5. That's 36 weeks. Well, in a week, there's 168 hours. So if I take 36 times 168, that gives us 6,048 hours. So you can see, you can start to get a little more accurate with what you're doing. And this gets to be important when you're trying to sell projects. You don't want to oversell them. By using our first guess of 10 months out of the year, that potentially could be overselling the energy savings. And while that may get the project implemented, there may not be some happy people on the other side when they don't see the savings that they thought would be there. So you probably want to try to make sure you get these estimates of time down as close as possible. So now we have our average KW. Take in. Another thing I haven't showed you yet is you can put boxes around these things. And I'm going to box this in. So now I kind of put a border around it so you can see it. So now I'm going to go and calculate kWh per year, which is just a matter of taking the average kilowatt hours over our measurement period, which for the after case is 9, and multiply it times the number of hours that we want to look at savings for. And so if I go equals 9 times, in a spreadsheet is the asterisk times the number of hours, I get this number. So if I look at this, it's it's kind of blurting out what I want to see, but it will have a dotted line around the cells that are being referenced. You know, I'll show you. If I say equals that times that, it now if I highlight this and I go F2, it will show me the two numbers that it's using in this calculation right up here. So that's a really handy way to find out what numbers you're referencing. So again, this is giving me kilowatt hours, but it's giving me all these decimal places. So I want to go up here and just arrow over. So I have no significant digits, and it gives me 54,341 after. And I'm going to Control C. I'm showing you, talking through all these different ways that I'm copying things. Control C is copy whatever you have highlighted. And I'm going to go over to the next cell, and Control V will paste it into that same equation in that cell. It will move the referenced cell numbers, the same number of columns and rows you move to paste it into. So in this case, it's just we're going over one row, so it's going to take the two numbers above it rather than two numbers above that. So now if we look at this, we have kilowatt hours before and after. To get our savings, all we have to do is before, after. So those are before kilowatt hours. Here's our after. And I subtract them, subtract the after from the before. I get a savings of 6,155 kilowatt hours in my example. When you have gotten that far, I want to find out what other people are getting compared to what I have. Again, my data is a little bit different than yours. And I'm assuming that it could be different for everybody. Well, groups of two. AWH per year savings. So I'm gonna let you start getting those numbers together. I'm just gonna put a cost to this now as you're doing it. 0.094 per kWh, that's our cost. So I'm gonna put a $sign on this. And you see when I hit the $sign up here to format it, it truncated to just 2 decimals. Well, whenever we use a rate, we probably want to have 4 decimal places or 4 digits past the decimal place. So I'm going to put it that way where it's $0.0940 per kilowatt hour. So then our cost savings over that same period of time is just going to be a matter of multiplying kilowatt hours. So it equals kilowatt hours. Shift to asterisk to get that to be our multiplication times the kilowatt hours themselves. And we get $678.60. I'm going to go ahead and oops, I'm sorry, $578. Cost savings over the year. So Robert, what are you thinking as far as this type of savings?
You know,
Any
given the
thoughts on it?
fact that we spent all of, I don't know, even if we called it an hour of time, we got a pretty good rate of return on that one. $500 or $600 a year for an hour's worth of work.
Yeah, I'll take
Of course,
that.
that continues on as long as we maintain our schedules. And once we got them set up right in the first place, it'll take even less time to maintain them moving forward. And that's for one floor of a building and approximately 18,000 square feet. I don't think many of you have only a single building of 18,000 square feet. I think most of you have significantly greater numbers. So you can get an idea of where all of this can go.
Continue working on that while I talk through some things here. I've got 5 more minutes before I got to toss this back over to Robert. So the next thing that we want to talk about is energy intensity. Energy intensity is the way that you can look at a sort of benchmark of your building. You're looking at the units of energy per, in our case, square feet. That's the most common reference point is square footage. But I've done it oddly enough for units of production. One of the ones was for per linear feet of holes. So it was radiator hoses I was analyzing and guaranteeing energy use over. So analysis that we do as building managers, building operators, we're looking at energy use per square foot. Historically, what I've done is I've looked at kilowatt hours per square foot, therms per square foot. There's information out there about school buildings in different parts of the country, what type of kilowatt hours and therms per square foot that they use. You take and you consolidate that down into BTUs per square foot. That gives you better feel for not just your region, but other areas, and gives you an idea from a standpoint of non-weather related, what it can look like. So it's a better way, I think, for everybody to compare themselves to a broad range of facilities throughout the United States. Now, you do look at different regions. For instance, Florida is going to have a much different number than, say, Alaska because of weather. So there's going to be those regional differences, and that's what the beauty of Energy Star. It would give you energy intensity on a BTU per square foot basis that would allow you to compare it to your similar buildings in your region. And yeah, Damien's asking about heating degree days. That's another way you can look at the energy intensity. When I plot my data out for facilities, I will usually just for natural gas, because we don't have a really high air conditioning load here in Wisconsin. You look at BTUs per square foot per degree day, and you can plot that out and track it. It usually kind of sits along a linear line, and you want to make sure that you're not outside that line too far, because then you know you have a problem. Because it varies by the number of degree days in a month, you know, how cold it is at any given period of time, and the what I'll call shoulder months that we have heating available, but it's not necessarily cold out. Our BTU per square foot per degree day goes up. The colder it is outside, the more that BTU per square foot per degree day comes down. So you have to, at times, look at that degree day count one. So by having these benchmarks, you can get a better feel tracking your building year after year after year of how you're doing. So that's also allows you to take your one building in your district, compare it to another building in your district, and get a better feel for whether you're operating things similarly or as efficiently. Now, when you look at a high school versus a middle school versus a elementary school, those numbers are going to be different. High school is going to be higher than a middle school, not tremendously higher, but still higher. But they're both going to be higher, significantly, I guess significantly, I could say, higher than an elementary school. Because the elementary schools tend to be not operate as many hours. You don't have as many activities in them, and you don't have shop classes and all that sort of stuff. So they tend to be lower. Is anybody using energy intensity right now? I know, Adam, you probably are. And right in line with the energy intensity, you can look at and think
It
about,
calculates it automatically in Portfolio Manager.
yeah,
As long as you enter the buildings and everything right. I did it both manually, and now I'm just trying to build Power BI reports using the information directly from Energy Star Portfolio Manager. But initially I did all the conversions and all that, but all that information you can query.
Yeah. And that's the nice thing about Energy Star Portfolio Manager. It does all that for you. It
They'll
gives you,
also give you the energy cost intensity.
yeah,
You can see what the cost is per square foot in your building.
yeah. It makes a huge difference in your ability to control what you're doing. Because as it says, you can't manage what you don't measure. So that's energy intensity. With that, Robert, I'm gonna toss it back at you. And I'm gonna stop the share and then, well, no, I'll just leave it here. This is okay. Does this work okay, Robert? Using this, or should I make it full screen?
This is fine as far as I'm concerned. Sorry, I was on mute and didn't realize it.
I was hoping that was the case.
All
All
right.
right. Actually, I can just bring it up here. There we go.
All righty. So I don't remember if it was the first day or the second day of this class, you all asked if we could talk a little bit about variable frequency drives. So different parts of the country, different engineering teams, different staffing teams have different names for this device. And I'm sure you all know many of them. Which ones you use internally to your facility may vary. Could be variable frequency drive, adjustable speed drive, just calling them drives in general. If you start getting into the, especially the compressor side, on newer variable speed compressors, they call them inverters. But we're all talking about the same thing. Next slide, Ted. They're an electrical device that takes AC power in and controls the speed of a motor as its output. In reality, we kind of think of it that it puts out AC power, but it doesn't. It puts out DC. And we'll talk about that in a second. Typically speaking, they're associated with three-phase motors, but that is not a strict requirement. They do make single-phase input drives that will drive a three-phase motor, and they also make single-phase input that will drive a single-phase AC motor. Okay. We use them to have the ability to adjust our motor-based loads. So oftentimes this means things like fans and pumps for the most part, though also in more recent years, we're doing a lot more with compressors as well. But we're trying to adjust their speed effectively to match the load of our building. And doing this in as energy efficient a way as possible. Historically, we developed variable frequency drives as a replacement for DC motors. DC motors, it's very easy to control the speed. You just vary the input voltage. So if you want it to go faster, you give it more volts. Simple as that. DC motors are great that way. However, they are not consistent in their torque when you do this. At very low speeds, they have very low torque. And that can cause a problem, especially with things like pumps. So we also changed up or used inlet vanes or outlet vanes or bypass dampers. We used all of those on our fans for air handlers and rooftop units for a number of years. And they do work. Maybe not the most effective and certainly not the most efficient. So instead, we use variable frequency drives now. Variable frequency drives can also even sometimes, that's a big asterisk there, eliminate the need for balance valves on your pumps when you're dealing with hot water or chilled water. Next slide, Ted. So how variable frequency drives work. You can really get deep into this topic, and for anybody who's interested in electrical theory and electronics, it's actually really super, super interesting. But the short of it is they take usually three-phase AC power in, matching the voltage associated with that motor. They convert it over to DC voltage, okay, or DC power, DC electricity, whatever term you want to use. Once they've converted it over, they use some transistors called IGBTs, or insulated gate bipolar transistors, to switch that DC power very quickly. We're talking on the range of around 5,000 hertz is the default for most frequency drives, though a lot of them can go up into the kind of lower to mid-teens. I've even seen some that'll go up to about 20 kilohertz. But most of the time we don't want to go that high. Most of the time the default out of the box is what we go with, and it's not a setting that we typically play with very often. Okay, but we're turning these on and off to simulate a sine wave, just one of a different frequency than our input will initially provide us. Now, be cautious when you're buying variable frequency drives. There are some out there that are very inexpensive, and they use MOSFETs instead of IGBTs for their switching. And I know this gets kind of down into the weeds with it. And there is nothing wrong with MOSFETs when you are using them for audio amplifiers and things like that. But when you're using them for kind of heavier duty power switching, they have very short lifespans in comparison to IGBTs. IGBTs can handle a lot more current over a longer period of time. They just can't switch as fast. But for us, we don't need to switch things in the hundreds of kilohertz. 510 is plenty for us. So you can see our two graphs there on the left. Top graph, we have a standard three-phase power graph, phase 1, 2, and 3. These are all rotated at 120 degrees to each other mathematically. And we did how power is generated back on week 1. And you remember the generator spinning in a circle. Well, a sine wave is just a circle that's been drawn out. Okay. Below that, we have some DC switching frequencies. And Ted will hit the next slide for us, and we'll get a closer look at that. Okay. The top two graphs are just phase A and phase B, or phase 1 and 2, whichever you prefer. And you can see the lighter sine wave line drawn in. Okay. But what I want you to focus on... What's that?
Sorry, Robert, there would be a phase C too. We just only had 2 on here, that's all.
Right. What I want you to focus on is looking at the on times of that pulsed DC wave. So on the far left, we're going to start at an on state at the top and come down to an off state. And they're pretty wide on states and pretty narrow off states. And as we move to the right, and as that sine wave peaks, our off states get smaller and smaller. Okay? After we reach our peak and start coming down our sine wave, our ons become smaller and our offs become bigger. This is how we create or simulate that sine wave using pulsed DC. It's been the way we've done it with variable frequency drives for a long time. And our cheaper sine wave inverters that you can get for, so you can plug things into your vehicle, 120 volt devices, still use a very similar tactic, though they've gotten a little bit more advanced. Okay. Our phase B down below is the same idea. It's just rotated again that 120 degrees around our circle. That bottom graph is our single phase and shows the full cycle. The top two really only showed the top half of what was going on because it was only showing the positive values. If we go to full AC, which is what our motors use, we have positive values on the top side of 0 and negative values on the bottom. And you can see that our pattern very much matches this, okay? This is how we control the frequency. As we want a slower speed, lower frequency, higher speed, higher frequency. Next slide, please, Ted. And I know I'm going fast on the technical end because you don't have to know it to be able to use one. Okay? Why do we care about the frequency of the power? Well, because it's how we control the rotational speed of our motor, or RPM if you'd like. Okay? Here in North America, our default frequency for power is 60 hertz. The formula to calculate the speed your motor is spinning at is the frequency of the input power times 60 times 2, and that whole result divided by the number of poles in the motor. Okay? And by using 60 hertz as our default and the listed RPM on a motor, we can back calculate and figure out how many poles. But most of the motors that we're going to deal with here in the US are 4-pole motors. So at 60 hertz times 60 seconds divided by, or times 2 pole, or 2 magnetic changes, positive and negative, divided by our 4 poles, we get 18,000 RPMs. And that's the most common commercial motor we're going to run into, runs about 18,000 RPMs.
1800.
Most list it like 1750 or something like that. And that's because of slip that we're not going to talk about today. Ted.
1800, not 18,000.
1800, yes, thank you, not 1,000. Adding a 0 there is kind of important. Very few pumps or fans are rated to spin at 18,000 RPM. Sorry about that. All right. If we take the same motor and we slow our frequency down to something like 45 hertz, which would be 75% of speed, we come up with slowing our motor down to about 1,350 RPM. So that's why we care about frequency and how the drive works, both from a electrical standpoint and the mathematical side. Next slide, please, Ted. And of course, how do they impact energy? Well, almost all of our motors that we deal with in commercial buildings follow the cube rule, okay? And what that means is their input power is approximately equal to their percent load cubed, or times itself 3 times. And our percent load is about equal to our percent speed when we're talking about fans and pumps. Compressors get a little funky with that, but it's still kind of close. Okay. So if we assume we're running at full speed, our input power would then equal 100%, because we've got 100% divided by 100 to convert it from the percent cubed. 1 times 1 times 1 equals 1. If we drop that down to 80% of speed, or 0.8 of our maximum speed, multiply that 3 times, and we get 51.2% of our incoming power. Okay, so we reduced our motor speed by 20%, that's all, and we saved almost 50% of the energy used on that motor. That's why drives are so effective from a power saving standpoint. If you have constant speed pumps that you have limited down on their flow rate by balance valves, that's a candidate for putting in a variable frequency drive to save energy. And You don't have to add any specific controls for it. You just match the motor speed to the flow rate that you need in your building. It can be absolutely as simple as that. I don't encourage stopping there. I like putting on a little bit more controls and eking out that little bit of extra. Okay. We'll have time for questions at the end. I'm running just a little bit over, so next slide, Ted. Okay. This was one of those things that you specifically asked, was talking about putting variable frequency drives on existing motors and some of the concerns associated with that. I am generally a fan of putting variable frequency drives on almost every motor. They are so cheap anymore that they just really help in most situations. The ability to start softly instead of that hard bam on is beneficial from a maintenance standpoint. It doesn't do as much damage to your belts. It lets it ramp up slowly so you don't get that peak inrush of power as bad. Really positive. But there are some things we have to take into account. Number one, motor insulation. And you may have, when you're looking at this, found motors that are, quote, rated for variable frequency drives. And one of the things that they quote is insulation rating. Yeah, sure, whatever. To me, it's unimportant or not useful. What you should be looking at is the health of the insulation in your motor, especially if you're putting a new drive on an old motor. Though honestly, you should be looking at the insulation quality on every one of your motors because it can be a predictor of electrical failures. We do this by testing the insulation with a device called an insulation tester. I know, inventive name, right? Or commonly referred to as a megger, or in the process, megging the motor. And it's just testing that insulation quality. These numbers are typically shown in millions of ohms or mega ohms. When you're testing a motor for insulation, you're looking for a number above 100 mega ohms. Above that, life is good. Below that, you need to start thinking about this motor. If you're kind of in those upper 90s, upper 80s, it's still in good shape. You've got some time, but it's time to start budgeting. Okay. If it's below 50, it probably should be put on the emergency budget. And if you can schedule and do a replacement during some downtime, that's probably a good idea. If you see a number below 20 mega ohms, you should order a motor and get it replaced this weekend if you can, because its failure is imminent at this juncture. And you may, if you look back in your facility or your maintenance reports, find that that motor has already tripped a breaker or blown fuses once or twice. More of that activity is coming, and soon it will just, you'll reset it and it'll just blow them right again. Okay. Insulation rating is one of those things that they talk about with variable frequency drive rated motors. That's garbage because the peak voltage that we normally rate our motors for at 480 volts is above 679 volts. That's our peak voltage. So any of our insulation has to already be rated higher than that. And most of our variable frequency drives don't spit out voltage higher than 600 volts. Now, they will tell you that variable frequency drives degrade the insulation of your motors more quickly, and that is true, though not screamingly true. You'd have to talk to one of the motor manufacturers like Balder to get real data on that, or the variable frequency drive manufacturers should have similar data. But it's very, this way and that way, depending on who you talk to about the drives. Oh, and you should, once you start testing the motor insulation on your motors, and I encourage this on all motors. It is a great predictor of electrical failure on a motor. Do it on an annual basis. Save that data, start building historical graphs, and you'll find out when those motors are going to die sooner. Dan, you're just ahead of me. Ted, next slide, please. The other thing we have to be careful of is with adding motor frequency drives to motors is our bearings. High frequency pulsed DC can cause eddy currents to build up in the rotor. That's the rotational part in the middle of the motor. And there's good news and bad news. Good news is that current that builds up, it is virtually no threat to people. It self-discharges. So once it builds up enough, it just arcs and is done. But the level of arcing and the current involved is not something that is going to interfere with people or anybody's really going to notice, except for our poor bearings. Because since our bearings are the contact point between the motor housing, which is effectively ground, and the motor shaft, which is associated with the rotor, well, our bearings are that path of conductivity. And as I'm sure many of you know, there are these devices called arc welders that use electricity to move metal from one side of a source to another. There's also electrical discharge machining, which is used to remove metal. These are both using electrical arcs, just like we would run into in our bearings if we're not careful. So we want to install something called a shaft grounding kit. Normally, this consists of a slip ring setup or a couple of brushes so that our housing for our motor is electrically connected to the shaft at all times and provides an easy way for those eddy currents to drain down to ground without going through our bearings. Okay, they're not expensive to buy, 50, 60 bucks if your motor doesn't already have one. They can be a little bit of an annoyance to install, depending on which ones you get. If you do have to install them, I do recommend the split type version so that you can, like 2 half moons, add it to the shaft of the motor. Trying to do the full ring ones after a motor has been installed is a real pain because you have to take off the end device or the coupler. The other thing we can do to help the life of our bearings is by using a non-conductive grease. Because as our motors spin, ideally those bearings don't ride metal to metal, they ride grease to metal. So that grease can provide a layer of insulation and further encouragement for that eddy current to discharge through the grounding kit instead of through the bearings. I think I have one more slide here. All right. Bypasses on variable frequency drives. This is a pet peeve of mine, has been for a long time. I hate variable frequency drive bypasses. They're often specified by design engineers and for reasons. Okay, they are a way to bypass the drive if something goes wrong. The problem I have with them is that they double the cost of the drive. So if you have a building that has 10 variable frequency drives, you're now looking at 20 times the overall price, or still doubling the price of the initial, when in reality, you could buy 1 or 2 spare variable frequency drives to swap in if the drive itself dies. Our modern drives, pretty robust. They last a long time. When you try and use the bypass, there are a couple of concerns. One is how many motors in your building can actually run at 100%. that already have a variable frequency drive on them. Air handler fans, rooftop unit fans for a variable system, not going to happen. Your pumps, yeah, you can run those at 100% if you have to. But honestly, again, doubling that cost, big wire nuts aren't that expensive. And yeah, it takes an electrician to do it, you're right, but can save a lot. The other thing is, most of the time anymore, it's not the drive that fails if you're doing proper maintenance, it's the motor itself. So if it's an electrical short in the motor, for example, our drive will create an error. And so when a technician walks up, what normally happens, unfortunately, I've seen it happen, is technician walks up, says, huh, the drive's in error. Well, I need this running, so I'll just put it in bypass. They hit the switch, and now we have nowhere near the electrical safeties that we had in place before, and something bad happens. Hopefully it's as minor as blown fuses or a tripped breaker, but sometimes it's significantly worse. Okay, maybe we have destroyed a motor that could have been repaired previously, or worse, maybe we've hurt somebody. Okay, that's why I'm not a fan of drive bypasses. I'm not saying they don't have functions. In critical applications, fire sprinkler pumps, exhaust fans for fire, totally get it. Yes, give them a bypass. Most of the time, a bypass actually isn't as helpful as everybody thinks it is. Okay, sorry I ran over with that. That was my 2 cents on variable frequency drives and bypasses. Does anybody have any questions on, well, I guess if we hit the next slide, anything we've covered today? Drives, bypasses, energy usage, energy calculations, spreadsheets. What do you have? You've all been really quiet today.
Crickets out there. It happens. There are days like that.
Yep.
At least
I
here it
think
looks
it's
nice and sunny
Friday.
outside. Maybe that's... What was that, Larry?
I said, I think it's Friday.
Definitely Friday.
And it looks bright and sunny outside here. I don't know what temperatures are, but
Okay. Well, since we don't have any questions at the moment, because both Ted and I ran a little bit over, we will go ahead and take a short break. We'll 5 minutes. We'll be back at 20 minutes past the hour. Any questions you have in the meantime, throw them in the chat. We'll answer them in the chat and then hit up the questions right after. But be back right at 20 after so that we can get concluded. I'll also put the survey link back in the chat again a second time for anybody who missed it the first round.
back in 10,
Back in 5.
5.
All righty. It is 20 minutes past the hour. The survey link is in the chat. We had one question over the short break that I wanted to address. Damien asked the question if they are working on coming up with more efficient VFDs, specifically looking at modified sine wave versus pulse width modulation. Modified sine wave is probably what your higher end, like battery powered inverters and stuff are running, because it provides cleaner power that makes electronics happier. I know there are some companies that are experimenting with that in the VFD space, but the truth is the motors that we're connecting really don't care much because they're just a big coil of wire. So, you know, that improved quality really doesn't do much. Historically, our gains have come through with improving our switching technology, which is why we ended up with IGBTs. There's more details about that in the chat if you want to read the nerdy details about it. What is generally more effective than improving the efficiency of the drives themselves is the efficiency of the motors, so that we're using less power even when we're outside of a drive. It's just like improving the efficiency of transformers. It can be really effective and additive. That's a great question, Damien. I appreciate you asking it. Any other questions? All right. If you think of any, throw them in the chat. Again, the survey's there. We are going to pass it over to Larry, I believe, is going to lead some discussions as we close or come to our conclusion of this training.
Indeed. Thank you so much, Robert. And since you've all had time to do a little reflection on the training, as a result, perhaps, of doing the survey, I thought I would kind of open up the floor for some kind of general thoughts about the training, things you think maybe we didn't cover enough, maybe you'd like to see them in future trainings. Were there any areas that you thought maybe we spent a little too much time on? And in particular, I'm very interested in hearing your thoughts about the online interactive building simulator that we've introduced to all of you. Was it user-friendly? Or if not, how do you think it might be improved? Especially relative to how you might take these lessons learned back to your own institution. So I guess maybe I'll pick one of those things to start off with. How does that sound, Robert and Ted, or anybody else out there? Someone has something burning they want to pipe up on, go ahead.
Well, I'd just like to say that
Jessica.
I'm really grateful for this training. I feel like it's been, some parts of it are maybe too deep for me, but overall, like, it's just been really, really helpful to me. So I'm grateful. I did put a couple of comments where you might improve in my survey, but that is not to detract in any way from how really valuable this has been to me. Thank you so much.
Yeah, well, thank you for that. Much appreciated. Hey, we are definitely looking for constructive feedback. So we wouldn't want everyone to say, wow, this was the greatest thing since sliced bread, and not have anything else to work on, right? So, well, what
You're muted,
about,
Ted.
not, I'm sorry, go ahead.
You're muted, Ted. Whatever you said, we missed it.
I said Larry may not want that all excellent reviews, but maybe Robert and I do. Just kidding.
Well, yes, I understand. Instructors, of course, you all want rave reviews. Rate my professor. Yeah, I've seen that website. Some of those comments can be brutal. Yeah. Um, well,
Well, we do
I-
want to improve. We really do.
yes, yes. Okay. Well, since the building simulator is definitely very critical, continue to offer such online trainings, why don't we start with that piece right there, right? What did people find that worked, or things that again could be improved upon?
So Regina says that she mentioned in the survey that it would be nice to have an undo button in the simulator. Yeah, that would be great, wouldn't it?
Okay, interesting. Yeah, good comment. Absolutely. You just Control Z, huh?
Yeah. Damien really liked the discussions from the fellow colleagues. So glad that that worked out well. Like I said, every time there's a lot of knowledge in this group, and Ted and I by far do not have the ultimate on any of it. So it's glad that everybody who shared could.
Yeah, we have a certain perspective and experience background, but not everything. But go ahead.
I thought that the building automation system simulator was a really good interface to engage with. I thought it was, just having worked with only one type of proprietary, piece of, automation equipment for the last 10 years, and being able to jump over into the seat of, something that's different. Um, I just thought it was a good experience. I thought it was clean. Um, the information was spread out nicely. I mean, yeah, there could have been some color or some graphics, I guess people like, but I thought it did an excellent job for the experience.
Good. That's good feedback. No, this is really the first time we've been able to roll that out, and it's something that we intend to improve upon every time we do this. So, although I don't think we have any influence about that undo button, by the way.
Yeah, unfortunately, we are using a commercial product there, just like you are in your buildings. This is literally a building automation system. So undo buttons are, I've never seen one in any of the systems. So as nice as it would be, and believe me, there are many people who agree with you. Not something that I'm aware of that exists.
That's curious. I wonder why that is. Just not something that really appeals to the software engineers.
More so that it would be really exceptionally hard to implement from a programming standpoint, because there are so many things that can be changed, and undo relies on the logging of those changes in a way that it can be reversed. And
Okay.
maybe we'll get there. That would be awesome, because I know a lot of people would love that ability. Me included.
There's a comment in here about, the fact that that simulator provided a base for everybody to be going from the same point. And that's true. And that I think is important, so that everybody, if everybody brings their own system into to work with here, it's just going to be all over the board. So this does provide that base. And actually, the main thing I think it does, it actually provides something that we can do online together, which is really important. Because then that interaction between everybody's really important.
Now, Robert, I know you had to tinker with the display to get the scales to read appropriately. I mean, especially since we were using 1 second intervals just so people could see changes more rapidly during the brevity of our training.
Right. You're talking on the trend logs, right?
Right. Yeah. Right. So just kind of curious about kind of people's kind of feedback about that. Did they feel like, again, it was legible enough? And I think Gene mentioned something, sure, we could always add some appealing graphics, but in terms of useful legibility, yes. That's something we're very much interested in.
Yeah.
And Robert, that's largely controlled through the BassView 3. Right.
That's correct.
Yeah.
The environment that we have to build building automation graphics is really reliant on whatever manufacturer you're working with, whatever their software is capable of. And believe me, nobody has there are some companies that make some very pretty graphics out there, but nobody has the level that we're used to with being able to edit documents and implant data and pictures, or what we're used to with web pages yet.
Mm-hmm.
They're improving, don't get me wrong, but they're behind the times.
Yeah, well, I would imagine with generative AI that kind of those graphics might rapidly. Oh, you're shaking your head. Okay.
Sorry, I have opinions. I'll keep them to myself.
Oh, that's okay. I'm sure they're well grounded. What about using the simulator for troubleshooting? Is that something that any of you would be interested in doing, say, in a forthcoming training?
I think somebody
And-
had alluded to that in the chat earlier, that to kind of put some things into the system that have to be found. I think they used the word puzzle, but troubleshooting is what I read into that comment. So that's good.
Looks like the answer is a pretty solid yes there from the people responding in the chat.
Okay. Very good. Can any of you offer, say, 1 or 2 kind of scenarios that you've encountered frequently with your own systems that could be used as the basis for troubleshooting?
I've found recently, especially since we've crossed over here in North Carolina to more cooling degree days, that we're seeing some of our supply fan motors uh, or belts breaking. And so when I'm looking at when we get a comfort issue and I get to it before the technicians, I can see that the supply fan command is calling for the supply fan to come on, but the status shows that the supply fan is not running. So that's, to me, that's an indicator that we have possibly a failure with the supply fan. And I mean, that's the light issues, but that's what I've seen recently. And you know, mm, I mean, that could help to, if you're looking at and you guys, let me go back to the graphics issue. You did have some graphics. I think there was VAV box there, and an air handler, if I couldn't, if I can remember. But whether you're looking at that or the raw data of information that's provided, it begins to try to keen your senses to looking for specific things possibly that are associated with the particular seasons. I don't know. Just a thought.
Jessica, I think you had unmuted and we're had a suggestion.
Yeah, I was just gonna mention on the troubleshooting side, I mean, maybe other people are way more experienced on this than me, but I get a call about a lack of heat or a comfort issue, and I mean, I've learned in this training, check the alarms first, but there's probably a better like sequence of what is the most efficient way to check out this problem from a building's automation's point of view before pulling up trend logs, like what would be the steps that make it the most sense?
Makes good sense.
Yeah, almost like a kind of troubleshooting checklist. If this is a symptom you're seeing, here are some things to consider. All right. And then also, we're certainly interested in hearing more just about the kind of the length of the training, right? The number of sessions. Do they seem about right? Or brief?
For myself, we're right at the end of our school year, so like this is crunch time, and the last 2 weeks have been insanely busy. So it's
bet.
from a length perspective, having a 4 or 5 hour class, even once a week, it's a lot to try to keep up with the rest of my stuff. So if you wanted to spread it out a little more, maybe into 2 hour classes or not right at the end of the school year, that would
Right.
be cool for me. We work all summer too, so that anytime but May would be better for me.
Understood. Understood. Right. Right.
Yeah, I agree with that end of the school year part. For sure.
You have no idea how happy we are to hear that, Jessica, or Ted and I are happy to hear that. Jeremy agrees. Kaylee doesn't particularly like the idea of summer because it's during construction season for schools. Totally get that. I started out doing controls on schools, so I absolutely hear you there. Gene seconds that one as well.
Right. So I guess if we were looking at another 5-week training, we'd want to start, maybe end of March.
So that would be a follow-up would it be better for you folks, specifically in schools, to do a training like this earlier in the spring? Or would it be better to have it happen early in fall or late fall, early winter? When on your school or on the year, do you think would be best for you and folks in your position or at your institution?
But for us here on Florida, can be any time of the year because we always the weather that we have, we always busy. It doesn't matter like spring or summer or winter time. Yeah, we have got that type of busyness that we always busy. But anytime March, April, at least with us, it's okay.
Okay. Thank you, Dan. Anybody?
Yeah, I would also imagine that some of you, your schools, your districts, might have a spring break. All right, so hopefully that might kind of alleviate some of the pressures and give you time for things like this.
Yes,
Of
sir.
course, I know. Yeah.
Yes, sir. Yeah, our spring break is normally on March between 18 to the 24. It's all depend of the setup of the year, but it's kind of, yeah, between 16 to the 20th. Yeah.
Okay. Yeah. And of course, that will vary from district to district, but at any rate. Yeah, that's good. And now, would you all be willing to maybe attend a follow-up webinar, and it can be brief, right? Maybe, let's just say 8 months from now. I'm just kind of arbitrarily saying that. So we might be able to discuss what things you were able to implement as a result of the training. Because I think ultimately, we always want to know what the potential impact is of the training itself, not you delivered it to.
Yeah, because we want to move that bar. We're doing this because we want it to be helpful for you and your buildings to help you do a better job at what you're doing.
Yeah.
And we would like to have that feedback as to how is that actually happening down the road? You know, what did it help you do better? Are there any real concrete things you can tell us? Stuff like that. Or was it something like, yeah, you know, that was really good training, but you know, didn't really use it every day or something like that, or didn't use it at all. I know we know it's going to be somewhere in between there, but we want to get that feedback so we can start to hone in on the things that are helpful and a little bit better when we have that feedback months down the road.
Yeah, at least on my side, I would say it was a great training. I know we have quite a few supervisors that on the HVAC side and control that they wasn't able to sign in because kind of time or busy dealing with a lot of stuff and they couldn't sign in. But now every week talking to them, I'm explaining detail of the training. They said like next time if they put something again together, let me know and I was signing because I wasn't able to sign it this time. But yeah, it's something
Yeah.
great.
Yeah, will do. And I think, of course, hey, we'd all love to hear that as a result of implementing some measure, your district was able to save money. And we understand that it takes time to be able to assess that. Probably a good year's worth of data, at least. When you say, Ted?
Yeah.
Yeah.
I mean, in the ideal world, you look at a year of work that has been geared towards making an impact and look at that for utility bills and then make the evaluation. But like we went through in calculations today, you can do it in other ways in shorter periods of time. So anything
Yeah,
else
okay.
there, guys?
Well, I mean, yeah, I think what we'll do is let's just say again 7 or 8 months down the road, we'll send out a mini survey, if you will, or just ask again whether you'd all be interested in reconvening, so we could just do that kind of brief follow-up with you. And then we'll try to schedule it accordingly.
Well, and the other thing that I want to jump in, just make a comment about was this high performance building operations professional certification. Whether you're looking at going towards taking that and getting that certification or not, just that it is out there. We're part of why we're doing this is feeding into that, where we want to elevate the level of our field. People who run these buildings, we're often not recognized for the effort we put in. We're not recognized necessarily for what we do to take this building for up towards high performance. And I realize that everybody's at different levels of being able to do that. But as you gain more experience, you may want to get that taken under your belt to then show to your corporation, to your districts that, hey, I have passed this. I have this level of skill that I can bring to the table and help out with getting our buildings to a better level. And I see Robert brought up the website for it. I don't know if you want to try to just go around a little bit there, Robert, and talk about it some more. But
I'm not familiar enough with the website, but
okay.
If you want to just take over on the screen share and pull it up on yours, that would probably be the better. I was just the backdrop to talk against.
I can do that. I'm going to replace yours, and I'm going to go to mine and share. So what I have, I'm going to go to this slide presentation, just kind of give a quick background on this again, where this was developed by a bunch of subject matter experts, and we took years to go through information as to what type of requirements and what type of knowledge levels people would need to get this level of certification. Because there's other certifications out there. There's a building operators certification, BOC, that's been running for a long time, and that provides the base level of understanding for somebody who's going to go into this next level of high performance building operations, because that provides you with the understanding of building systems. It gives you a basis on energy conservation, and gets you introduced to Energy Star and tracking of energy use. So it's a good certification to have. But then you can take that to the next level by going into high performance. And this particular certification, step through this a little bit. It looks at commercial construction and building operations. It's trying to get you to the level you can work with these different systems, make them integrated, and get things up and running. A lot of the things we've talked about here, that going towards a more integrated approach with your building systems and pulling information from your maintenance management systems and tying into the different aspects of power over Ethernet and the Internet of Things can really be helpful. But the goals of this certification are to create a national standard for knowledge and skills for this high performance building operations professional. And that word professional is important, because that's taking the field and recognizing that, hey, we do a lot of work here that's really intense from a perspective of understanding all these different systems. And it's just not going and understanding how to install an air handler or replace a motor. These are all things that we take this to the level of building systems and the whole operation, the impact on our budgets, the impacts on our energy, all this integrated together. this certification is ISO 17024 accredited. We're going towards that. I don't know, Larry, we don't have that certification yet, do we?
No, we don't, but we do intend to apply for that.
Yeah, and the reason we don't have it is you can't just apply for it. You got to go through all the steps first, then you can apply for it. And so we've been going through all the steps, and it's quite rigorous. We've had, I don't know, Larry, is there well over 100 people involved with helping go through all this so far?
Yeah,
Maybe even more.
likely. Yeah.
But it's something that it shows a level of professionalism and knowledge to really get buildings to working better for comfort of people in space, the health of people in space, and towards knocking down on consumption. It's something we can take to our bosses, our building owners, and say, hey, you know, you can hold this up and say, I've got this. I'm doing good. You can use it to help leverage a little bit better pay, a little bit higher positions too. And so, I mean, that kind of, I think, tells you, gives you a good background on what's there. And I'm going to go to hpbop.org and get you on that quickly. And then I'll pass it back over to Larry. Are you seeing this?
Yes, sir. Just got
Thank
loaded.
you. Yeah, so it's an application process to go through. You go apply now, and it will get you to the point where you start to fill out the data on applying for it, background, but there's different criteria involved here. This talks a little bit about the certification. Talks through there. You can click on any of these links. A lot of it goes into information that we've already kind of covered quickly here. Eligibility requirements are all listed here. And you know, it's not something that just anybody can do. You have to have some background to be able to apply. There's a handbook here, but you have to log in to get the handbook. So you're going to have to register or go through the apply now. I guess. Yeah, apply now, and that's how you get. Yes, Larry?
Yeah, I just wanted to add, Ted, there's no cost to become a registered user on the website to be able to download these documents.
And there's information on how it was developed. The DACM was done with a lot of subject matter experts from around the nation contributing to it. And we're just in a process. We developed a form for people to use to be recertified. So it's recertification requirements every 3 years. So there's a number of steps. It's got a lot of guts behind it. We put a lot of time and effort into this over the years, and it's something we have that we hope will continue to build. We have how many people, Larry, right now? 40 some?
About 40 have passed the exam so far. That's right.
Yeah. So if you have more questions, you can reach out to us, or you go to the website, and if you respond to the website, Larry is monitoring that and can get questions out to us if we need to answer them. So I guess that's about it. Larry, you want to take over?
Sure. And just so for what it's worth, you all kind of understand sort of the relationship between Best Center and then the National Alliance for High Performance Building Operations. Best Center developed the certification, but NABO, as we like to call the nonprofit, is the owner and the manager of the certification program, and it is a spinoff from Best Center. Okay. And I see that Peter Crabtree has joined us, so I am going to invite him to pose some questions to the group or make any kind of closing comments.
Well, thank you, Larry. Have you received comments back from the group yet?
Yes.
Okay. And I just want to thank everybody for attending, and we hope that this training has made a difference for you. And we'll be looking at your survey results and continuing to improve what we're doing with with that feedback that you've given us. We really appreciate you taking out the time for this training, and we hope it makes a difference for your work in the future. And I really want to thank our instructional team, Robert and Ted and Larry as well, for their work on making this happen. And of course, Jing Jing and her team at Lawrence Berkeley Lab. So back to you, Larry.
Yeah, well, of course, access to resources will continue to be important. And Robert and Ted, right, as far as I know, the recordings will continue to be available, right? So for those of you who wish to review any of our sessions again, it's right there. You can also offer that to your colleagues who were not able to attend. Now, what about the link to access?
Bob test.
Is that good for?
So the sessions should be good to review for about 90 days. Bob test, we don't know how long the lab will let us leave it up at the moment, but I'm hoping to be able to convince them for at least the next 30 days. So your links should be good for that time period. And again, feel free to make changes as you like, see what happens. It's a simulation, so there's no equipment to break and no customers to be irritated by being uncomfortable. So experiment and learn things.
Yeah, we will follow up with the lab just to confirm, again, the duration of the ongoing access. All right. Well, that's all I have on my list. I certainly look forward to, we all look forward to reviewing your survey responses. We might have a few questions for some of you, so don't be surprised if one of us kind of reaches out to you with those questions. But yeah, I thank you all for taking the time out of your extremely hectic schedules to participate.
Yeah, and feel free to reach out to us if you have questions.
Please.
Yeah, and we look forward to that, I don't know, somewhere 4 to 8 months out, meeting with you again for half hour, and just seeing what type of benefits you've had from this. Gene asked about whether it's going to be a certificate of completion. We can get that out there, can't we, Peter?
I'm sorry, what was your question?
A certificate of completion of this training.
Yes, we can.
Yeah, absolutely.
Yeah.
So we'll get that out. We'll have Kim work on that. All right. Well, thank you, everybody.
Yeah, seriously, you've been great to work with. You've asked really great questions, brought in some really interesting and fun experiences, and we really appreciate you being here.
Yeah.
Thank you so much. You all have an excellent Memorial Day weekend and much continued success to all of you. I know some of you kind of jumped into the role, or maybe, yeah, you were kind of thrown into the role of becoming a building operator or, you know, your building management system operator. So yeah, I salute you for being resilient. And Robert, do we want to end the recording?
Yep.